All right, welcome back. We are Game 2014 in the fall 2021 semester at George Brown, and it's week 13, part 1 of our broadcast and recording. And got a couple of things to talk about today that we kind of did already with the first section. You guys are the second section. We're sitting at week 13, and one of the things we talked about was, you know what, we have a couple weeks left at the end of semester. And one of the things that we were talking about is this practical test effects. And there's not that many of you, but one thing that I'm asking from you is feedback. I want to get some feedback in terms of the tests. So there's a couple of options, and I'm going to give you a little poll here, right, that I gave the first class. And let's see if we can do this together. So go to polls, and I want to edit my poll. So we're going to duplicate this one. And let's modify it. We'll call this the final evaluation poll. And that's the one that I want. We can get rid of some of these other ones in a sec. But let's go back to this and see how this works. And I'm going to launch the poll. So you'll see a poll come up in your screen. It's going to look like this. For people who are online, who don't have access to it, I'm sorry. But what I'm looking for, there's only 4 of us here, so I'm looking for some feedback for a couple things. So one, there is going to, in the last evaluation, to explain what these results mean, I have a couple of options. One option would be, let's do a final presentation video based on assignment 2. That's one option that I was thinking about. So that is this option right here. Final presentation video pre-recorded based on assignment 2 that you're going to have submitted to me that takes the place of the final exam. The final exam is worth 10%, and I'm going to ask you to kind of do a gameplay video, more of an extended gameplay video for about 5 minutes, talk about your process and what the game is and all that kind of stuff in almost like a mini, kind of game con at the end of semester. We'll probably either run it live for people who want to run it live, or for people who don't, you can, kind of submit your recording. That's not option number 1. 2, you're going to get a practical assignment as an option. So a week-long practical take-home assignment, not related to A2. The biggest problem with this one is both, you have to have A2 done. So it's assignment 2 altogether. If it's not done and you want to make a video that doesn't do well, you make a video for A2, but this is almost like you're going to make a little presentation for the class, Herman, where you kind of do gameplay. You talk about a few things other than code. It's not a code video. You're not going through your code. You're actually talking about the game that you made, why you made it, and all this kind of stuff, almost like to the class. So a different kind of video. 5 minutes, no more, no less. And that's what the presentation video would be. And it would take the place of a final practical exam. So you don't have to do that. If you already have A2, this is just an extra little video for me for your final presentation. I'll have some slides that you also have to include. And that's really it. So those are the 2 big options. The other one is a final presentation video based on A2 or a practical exam not related to A2, your choice. So those are the 3 options. There's also another one, which is if you want me to create a true-false multiple choice test yet again, I will. You've done a couple of them this semester on theory tests. I can make another theory test on some of the other things we talked about so far. I can do that too. So those are the options. So now with that information, armed with that information for the 4 of you, I've got some input from the other people. I had 15 people answer. And if I get you 4 to answer as well, then I can get some information on what you guys think is the best course of action. I got 1 person. I need the other 3 of you to answer, please, if possible. Is the A2 video shown? It's optional, Michael. If you want to show it, I'm going to make it so that the A2 video is going to be something. If you want to show it in class, then you can. If you don't want to show it in class, then I'll make it so it's optional. So that way, if you don't attend or if you can't attend, then it's okay. Okay. So week-long take-home practical. Anybody else? We have 2 more. Sorry, there's 3. One more person. One more person has to answer. And I'm going to take all this into consideration because I've had answers from all of them, and then I'll share the answers with you. Okay, so I got a couple of things like that. Good. All right. So I wanted to thank you for that feedback. I want to get that information because at the end of the day, what I want to do is I want to compile that, and then we'll talk about it next week, where I give you a kind of a sense of what we're doing for our final practical test. Okay, is it practical? Is it going to be a video? Is it going to be a true false multiple choice? Any of those things are going to be fine. So make sure the poll is closed, right? Poll is closed. Yeah. Okay, cool. All right. Any other questions around that? Your head says 2, but your heart says 4. Okay, I know. It's tough. So some people want to do it. So there's people in the first section that were like, yeah, rah, we want to show off our final version of our A2. But what I'm trying to do is make it so that it is lighter for you guys for week 15. So it's not like a killer week and all that kind of stuff. Okay, that's what I wanted to avoid. And that's why I recommended let's think about, kind of removing our final practical, assignment and giving it something else, some other kind of thing that we can do together. Okay. All right, so that is this. Let's move on to the topics that we're going to cover. Lab 10, again, due this Friday. We have a bit of things we want to talk about in the Unity demo. One of them is a retro dust trail. We're going to do it in actually this order. We're going to do the minimap first. We do have time. I was able to make it work. So minimap, retro dust trail, and finally camera shake. We're going to do that, and this is going to be with Cinemachine. So with Cinemachine. We're going to use all that. So those are the 3 things we're going to talk about this week. To start, again, what we have is a lesson from last week, Lab 9. So if we go up on here, I have Lab 9 that's here that we're going to modify, right? And so if you already have Lab 9 from last time and you want to continue, that's totally fine. I'm going to make a copy of Lab 9 locally. So again, locally, I'm going to go to my desktop. I'm going to go to George Brown and GAME2014. And then I want to make a copy of our last week's Lab 9, right? And I'll make that Lab 10. So we'll make a new folder. I'm just going to do it differently this time. Game 2014, fall 2021, Lab 10. There it is. Grab everything from Lab 9 except for the library folder. We've done this before. Copy it, move it over, and drop it into Lab 10 and do that build. Okay. All right. So that is the first thing. Hopefully you guys are up to speed with me because I think that's what I want to start with. And just want to make sure that we're good to go with everything else that we've got going on right now as we move forward. Just making a couple of adjustments here before we move on. All right, so now that we've got this, we want to load it up with Unity. So again, I'm going to go open, and I'm going to open up on the desktop, right? We're going to open up that file, GBC, Game 2014, and it's going to be Lab 10, no library folder, and open. It's going to do its thing. It's going to open the library folder, and we should be pretty good very soon. Okay, let's get to that. as we start moving forward with everything else. Okay, so this is loading up. So so again, the reason why I asked about it was they were like, hey, you know what, this is pretty crazy. We have a lot going on. I know there's a lot of people that are very stressed out around this time, and I don't want to add to your stress. I want to remove some of your stress, and that's why I was thinking about how can I do this based on the time frame we have left. So my thoughts are, if we can do something different. Also, I know people are all very stressed out about next semester. Remember, next semester we're actually going to be in person for at least one day out of the 2 days that we're together. So one of the days for me is going to be Thursdays next semester. That's starting on January 10th. And some people are afraid or stressed out about it because some people have moved away. Some people have, you know, they're in another country and so on. There's like a lot of stuff that's happened, and they're concerned. How can we, you know, kind of get back in and play again based on the fact that, or learn again based on the fact that we're far away? How do we do that? So that's something that we're going to be thinking about. I'm meeting with Alex to talk about outlines on Friday. You're hoping there's no days with both online and in person. Yeah, that would be very bad. I think they're trying to avoid that, Herman. One thing I can tell you is that for my classes, I'm going to also broadcast the lab live to give some options for people who, for whatever reason, that particular day can't make it. Also, some other things I'm probably going to do is if there's a cataclysmic weather day next semester, then I'll tell you guys in ahead. We'll know that things are coming. It's a cataclysmic weather day, and usually either the day before or early in the day of, I'll send everybody a note that basically says, hey guys, I'm doing things remotely today. Don't come in because it's really bad weather, right? So if anything like that happens, that's how I'm going to do it next semester. But every professor has their own you know thing to do, right? So all right, so we want to continue from last day, and we did some modifications. One thing we weren't able to do is visualize our line of sight. We visualized everything else. So if I run this thing, you can see that what we left off last day was we have this little guy. He kind of comes up like so, but there's a bit of a bug that we found when we were actually playing it inside the timeline. So one thing we did in the timeline is we had a turning on the player after 60 frames thing. And then what happens when the player, if we play it long enough, it ends? What do we do? What happens then? Does it last forever? You know, what happens? So Vineet was kind enough to send us a little, you know, kind of information that how it works. And what he was suggesting was something that looks like this. He says, take the timeline and make it go at least to the end of the music. That's something that's part of the problem, right, for the timeline bug. Because if we kind of make it over here, then fine, when the music ends, so does the player, right? The player disappears. So I'm just putting it out there because that is an issue. If the music lasts for a long time, let's say the length of the level, you know, and 8,400, you know, milliseconds, if you will, that's how long the timeline lasts. We can make it last like that long as well. So let's go into over here, way over here. And so we can make it so that whatever this number is, this is kind of our workaround for the player, because the player is going to be in the scene. So that's one thing. We found that was a bug. We also found another couple of things. One thing was we could not visualize, like I said, the script for line of sight. So in the player behavior script, let's bring up player behavior. And let's make sure that the other instance of my Visual Studio is closed. This one is closed. Then one thing we did was last day, we had a visualization technique to view the on-draw gizmos. And we drew a wire sphere for our player behavior. right? Um, and that's great. But what about if I want to visualize in the enemy behavior, so in our enemies, that's what I want to see, the enemy controller. In the enemy controller, we had at the bottom, we also have this on draw gizmos, a color green for the look ahead point, which is like our ground, and in look in front point was the same color. So when we actually look at the enemy, we can see that there's these two little diamonds, and you see kind of a visualization of what the enemy can see in the editor. And that's fine. But what I want to do is change some of this up so it looks a little different. So what you can do is, first of all, in the gizmos area, you can change the gizmos so that they're smaller. Okay, so they don't have to be that small. So I do that by clicking in the little drop down in the gizmos area. That's the first thing. And the second thing is, let's change the gizmo color. So in the look ahead point, as an example, right now it's this blue diamond. Let's make that so it is green. So it'll be a green diamond. And the look in front point, let's make this whole thing so that it is a yellow diamond. So you can't see the effects yet because there's more than one enemy, but that's what I want. And let's just go to the enemy itself and go to overrides and apply all. So you can see now there's a green diamond and a little yellow diamond. And the yellow diamond, I'm going to change this whole line to yellow. And the way to do that is when I go here, we can use this gizmo's color change to yellow for the look in front point. Okay. So now you can see that when we go back to the editor, when we save our script, you're going to see that the look in front point now has a different color. So we can see that there's two different things happening here, right? What I'd like to do is during the game, I'd like to visualize how the enemy sees the player. And if we try to do that, to draw a line between the enemy and the player all the time, I mean, we can do that. We can draw a red line, let's say, between the enemy and the player constantly. And if we were to do that, we were to draw a line, that's okay. But then we'd always see that line being drawn all the time. It's like, how far, should the enemy see the player at all? And what I want it to be done is more in real time. Can the enemy see the player? And then if it's behind the block, the answer should be no. Okay, so we kind of did this. We said last week that we did a for each loop, and we said if the collider for the player that's connected to the player is inside of a list, then see if we have a hit. And if we have a hit, only then do we want to draw the line. That's when we want to say true. We want to draw that line as long as we have a hit. Okay, so that's what this is going to be done. So I can't do it here because when you do it here, this is in the editor. And because the script needs to run for me to see that I have a collision or not, it would give me a bunch of errors in the editor. So we don't want that. We want to put it something like that's in here. So we can do a draw line down in here. So we can see, and we'll do a debug dot draw line. So debug draw line. And we want to draw from the start to the end. We can do that. And with some kind of color. All right, so start would be the look in front position. We have that information. And to the end, which is the player, right? Here is the player's position, collider transform position. That's the player collider, right? And then with a color, so we'll say color dot red. That's the color I want. So I want a red color of the line that's being drawn from our enemy to the player when they can be seen. The rest, if they're not being able to be seen, no line. Okay? Let's see how this works. So again, and I'm adding this in because some people have asked me for debugging. How do I see if the player has the line from an enemy perspective? How do you do that? Okay, so here's my player, yay, right? And in the scene now, we shouldn't see a line, right? But if I jump over, let's put the game over here. If I jump over the block, and I look here now, we're going to see that the line is going to be visible, right? And if I move the player further back, right, then the line should actually be longer because it's in real time, right? And if I jump up again over here, we're going to see that there's no line because I'm being blocked by this thing, right? It's kind of a little debug. All right, so that is that piece. I just wanted to figure that out. So for you guys, so that's something we were missing last time. Now I want to add something called a minimap. This is the first thing I want to add in. And sometimes minimaps are great because what they can do is if we have a very long level, we don't. But if we had a very long level, you can get kind of a preview of what's coming up, like enemies or obstacles, hazards, those kind of things. You can give your player a chance to look ahead and kind of have a much larger view of what's going on. Minimaps have been used in both 3D games and 2D games. I'm going to give you one that's here. So the first part of the minimap is we want to think about having an additional camera to look at the scene from a different perspective. So again, under cameras, I want to add a brand new camera in. So again, it's going to be a camera. And we're going to call this the Minimap Camera. Okay, it's a regular camera, like everything else. Now, we don't want it to overlap with the current camera we have. This is the current camera. Because they're on the same depth layer, the second camera will overlap and take over what we're seeing. We want actually not to render the camera here, but inside of a render texture is what we call it. Remember back to, if you look back at some of the things that we've done with, you know, back in the day, remember you were learning about OpenGL. And in OpenGL, when we were talking about OpenGL, we render our camera to a full screen quad, typically is what we do, especially when we're doing things like deferred rendering and those kind of things. We want to render our camera to a quad. And in this case, it's kind of similar. Instead of having a quad and a texture that we're going to render to, what we do is we want to render to an actual texture we can define here. So in our assets, let's make a new folder. Let's make a new folder called textures. We're going to add some things in there. And the first thing we want is a render texture. So I'm going to right click, I'm going to create a new render texture. And this render texture is going to be called the Minimap Render Texture. Okay. It's going to be like this, 256 by 256. You can change the size if you wish, right? And we're leaving everything else as is. That is what it's going to be rendered to. So now the Minimap camera, notice that we have an option, a couple of options here. One, I don't want a clear flag skybox. Let's get rid of that. So we're going to say solid color only, where it's going to render everything in black in the background. I'm also going to change the point of view from perspective to orthographic. Notice that automatically changes what I'm seeing. And I also want to, for the Minimap camera, I want to change our size to 20. So let's pull it back a lot more, like up here. This is what's going to be seen in the Minimap, okay? The far plane, we're going to keep at something like 30, okay? So that's what it's going to be. So from 3 to 30, 0.3 to 30, because we don't want to go too far out. That is our Minimap camera. We don't need an audio listener here, so let's remove that, because we can't have two audio listeners in the scene. And instead of our target display being the one we're going to target, we're not going to do that. Instead, what I want to do is use that Minimap render texture as a target. So notice under target texture, if there's nothing there, it renders to the display. Here, we're going to render it to the target texture, which makes it pretty much invisible at this time. Yeah, so that's the first thing. So Minimap render texture is where this is rendering. If we actually look there, we can see a preview of what the texture would see. This is what the texture is going to see. That's what the Minimap is seeing right now, this part. Okay, cool. So now that we have that, I want to add it to the scene, and I want to add it inside of our canvas. So in the canvas area, we're going to add a brand new object, so another UI object, and we want to add in a raw image. The image is going to be looking like a square right now. That's okay. And now take a look at the texture. It says raw image texture. We want it to be the Minimap render texture. Yay, there it is. And it's pretty darn small. It's in the middle of our screen. Let's make it so that it's something like 420 by 420. So pretty big. And I want to take this little Minimap texture that I have and move it to the top right corner of my screen, right? Something like over here, right? Maybe something on the top right corner over here. That's where I want it to be. Now, one thing to note is our rect transform is the center. If you want it to always be on the right, then you want to make the anchor to the right-hand side of the screen. I failed to do that for the first section. If you're watching it again, this is where I want you guys to do it up here, right? So that it's anchored to the right hand of the screen. Also, good practice is with the Minimap, just to visualize it, we want to take a look at the simulator and see what the simulator sees. So make sure it's inside of the safe area, okay? All right, let's go back to our scene. So we have our Minimap, but it's pretty weird, right? Why? I can see the background and it needs a shape. It's too big. There's some stuff that I don't want to see. So what I want to do instead is in the Minimap itself, let's turn off the ability for the camera to see the background. So the background is just going to be black, okay? So one way of doing that is in the background, in the environment area, we have in our world, our background layer and our platform layer and our depth plane. The background layer and the depth plane both don't have a layer. Let's make them so we can omit them. So again, in the default layer area for the background layer, let's add a new layer. We're going to call this background. And we'll also add another layer for the depth plane since we're at it. Background and depth plane. And then in the background layer, I can select the background layer. And in the depth plane, I can select the depth plane. I don't want to see the depth plane and I don't want to see the background layer in my Minimap. So I go to my Minimap camera and I can go to where it says culling mask. And now I can deselect the depth plane and the background layer. So background layer is gone. But now it seems to be invisible, right? So it kind of removed it and it doesn't have a background default color. So that is something we need to rectify. Okay, so I want the default color in the background to actually show, my background, right? So it's going to be black. I want it to be black. So a couple ways to do that is inside of the raw image that I put in. Let's call this the Minimap render. Minimap render, right? That's what that is. Okay. So this is where we actually have our the Minimap itself, and the Minimap is going to kind of point to this area where it's going to be rendered. That's the render area, right? What I want is I want two other textures that we're going to put on top of here. One that's going to be a mask. The mask can be any shape we want, and it's going to mask or change the size of our map so we only see what is in the mask. The mask is also going to color our background. It's going to be a background layer. And anything outside the mask, for example, this square that looks like a 420 by 420, we can make the shape whatever we want, like a circle. So let's do a thing on this. Let us Control D. So instead of Minimap render, we're going to just make it Control D and duplicate the Minimap renderer, right? But instead of a raw image, let's get rid of it. Let's get rid of that raw image. And let's change this Minimap render right now. We're going to call this the Minimap. It's kind of like a mask, if you will, but we'll just call this the Minimap itself, right? That's the actual Minimap. We'll call it the Minimap mask so we can differentiate it for now. For the Minimap mask, I want to add a component which is an image. Here's our image component. Let's put this where it's going to be. This is the image component for itself. And the image component, we can have a sprite. So what we want is inside the sprite, there are different options here, right? And in the joystick, all right, the joystick itself has a horizontal. If you look at the horizontal, it has a horizontal outline where it has a plane, an outline, and arrows, a ridge, and arrows. These are the things you can add in for the joystick. There's also another one that's vertical outline, right? So you can see that those are the things that they have. So those are things we can use. We can start thinking about how we're going to display this, or just an outline. If I look at the axis outline, you can say that the axis outline is like this, right? There's kind of an axis outline we can add in. Let's add this, we'll call this all axis. There's another one called all axis plane, like this, and plane with arrows. We just want to use all axis plane as a thing that we're searching for. So all axis plane is a circle. We're going to use that. And that is what the mask is going to be for our Minimap renderer, right? What we want to do is we want to take this mask and make it the Minimap render's parent. So take the Minimap render and put it inside of the Minimask. Now you're going to see this. But we want to kind of omit anything that's outside of this image. And to do that with the Minimask itself, we're going to add in a mask component. So mask. And what this is going to do is anything outside of this circle is going to be culled. It won't be drawn out here, 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 here. So even though our mask, our Minimap itself is a square, we're only caring about the stuff that's in the circle. In fact, let's make that circle smaller. So instead of 420 by 420, let's make it so that it's like something like 360 by 360. There we go. Okay. Again, make sure that the Minimap render is 420 by 420, and we can make sure that the position X and Y is 0, 0, 0. If we did that, if I change it to 0, 0, 0, that's relative to the top right corner of my screen, right? We don't want that. Let's undo. We want it to be the same. Right now, what's happening is it says that it's going to be it's centered to the right. Maybe what we want to do in this case is we want to center in the middle, right? So that is where we can say that if we made this 0, 0, 0, right, then it's right dead center. It's centered in the middle of our screen. But the Minimap, the Minimask, that is anchored to the top right, whereas the Minimap render is anchored in the middle. Notice now we're seeing a little bit of this guy, but nothing, this part here is not shown. Okay, so all we care about is the stuff inside. And that's okay. We can see this piece. But maybe what we want to do is we also want to have a border. So let us duplicate the Minimap mask, this part, duplicate, Control D. And then what we want to do is in the Minimap mask, let's get rid of the Minimap render. We don't want double rendering happening, right? And we'll change this Minimap mask to Minimap border. And we'll say that the Minimap mask is parented to the border. So we'll say take this and put it here. So now you see both are the same. And I want to change the Minimap border so that it is larger, actually, 380 by 380, where the Minimap mask is 360 by 360. Let's also make the Minimap mask is centered to the object, its parent. And let's make it so that it's centered, center, center. There we go. So you can see that's all centered, but the Minimap border is to the right. And let's change the Minimap border color to something like black. All right. Now it's really hard to see. If this was a light background over here and we saw a black, that's good. But the background is kind of brown and this black is lost. So either we have to make that a lighter color or we can swap these colors around. So in other words, let's change the Minimap mask. So we make that black and we can make the Minimap border white like so. And now you can see something that looks like this. And that is our Minimap. But if we were to run this thing, right, there's a couple of things you're going to notice. One, you can't see the player here, right? And also, if I move things, this stays the same because the Minimap doesn't move with the player, right? So knock him off, right? We don't see him anymore. Even though he's over here, it stopped, right? So we need to make the Minimap move with the player, and the player can't actually be seen at all, which is a negative thing, right? So some issues. We have some issues. And there's some problems. We can't even see the player here in our screen. Even if I'm, like right now, when I'm going into the screen, I can't see my player in the scene, right? Which is a problem. it's a real problem, right? So here's my player, and somehow the player is not seen. Why? Well, because it is disabled in the scene and it comes back enabled, but it's also at a weird number, 10.75 or whatever. And it's 10.75 for a couple reasons. One of them is because of the fact that Cinemachine kind of brings it back at that 10.75 number. So in order for me to do that, I want a mini map to follow the player, plus make sure that we take in this value so we can see the player. Okay, so that's something that we have to do. Let's make a new script, and we want to make a script called Minimap Follow. So create a new C# script, call this Minimap Follow. Minimap Follow script is going to be attached to the Minimap Camera. So grab that Minimap Follow script and attach it. And what we want the Minimap Follow script to do is get record of the player's location. So a public transform that is the player. And we don't want to drag and drop. Let's find the player. So we'll say player is equal to game object, find object of type, player behavior, and we want to use the game object.transform to kind of return that into the player. That's kind of a one-liner that does it all. So you find the player in the scene and then attach it. But we're going to have a problem, aren't we? Because the player doesn't exist. The player doesn't exist at the beginning, right? Because of our weird timeline thing. We added a timeline turning on the player after the scene and all that stuff. Guys, I'm going to turn that off just for this particular example. So in the timeline, we have this issue where the player doesn't exist yet. It's been turned off, and it only turns on after like 60 frames when we move the camera back, right? And that's kind of what we were fooling around with last time. Let's move this back again. Where we are. We've turned it on, but after 60 frames only. Let's just get rid of this thing. So the timeline does not bring the player in. And let's make the player in all the time. And if we were to do that, then we know that the player will exist. Here's the player. We know the player exists. Great. And then what we want to do is in the transform, we want to say something like the transform dot position of the camera is going to be equal to the player itself, right? The player transform dot position, right? Plus a new vector3 object that adds nothing to the X and Y, but subtracts something like 10, as an example, from the camera, so we can get to the right position. Oof. And now that it's attached, you can see that the Minimap Camera is here. I could drag and drop the player, but if I run it now, we should be able to see the player in the scene. There it is. And we can see that if I move, the camera moves along with me. Exactly. Okay. Oh, it's an actual, I think this block is actually wrong. There we go. It's hard. There's a bit of a hard jump there. Realistically, this whole thing should be a little bit lower. Maybe this will do in the game, in this scene, just, kind of hit the environment for the platform layer. And I'm just going to go to tile map just because I don't want to have that problem every time. And let's move that a little lower. So again, I'm just going to grab this in the platform layer. I'm going to surround this thing, and we'll make it so that it moves a little bit. Actually, it's not that one. It's let's do that again. It's actually this one. This one here is the problem, not this one. So move it down one step. So over here and move it down. There, there we go. And that is probably going to be okay. I think I made it too high, and that's why I'm always having trouble jumping over it. And it'd be really nice if this platform was a little longer, but whatever, I can't change everything right now. It's not really in scope. All right, cool. So now if I run it, you'll see that that is a little bit of an easier jump to make. And again, making level adjustments like this is not a bad thing, right? Whoa, now it's even too easy. But at least I can get to this part of the level, right? or I can get all the way over here, and you can see that the Minimap works okay. All right, so that is this part. That is the Minimap follow, and I'm mapping exactly to the player, just pulling back from the camera so I can see what it looks like. Can I put the Minimap camera in the player's hierarchy? Yes, you can. That's also an option, right? I don't think it's a negative thing to have the player, it'll follow the player exactly. The challenge is you need to do this anyway. You need to pull this out a little bit from the player because it can't be right on top of the player or it won't be able to see the player. So be careful about how you do this, whether you do it here in a script. One example, one advantage of doing it in a script, Herman, is what we want to do also is what if I wanted to make a lazy follow or I wanted to turn the Minimap on or off or something like that. A lot of times I find that having an extra script that's just for the Minimap is a little easier, more control. But it really doesn't matter to me how you do it. But certainly you can put it inside the player hierarchy itself, because if you did that, then it would automatically follow. All right, so that is the Minimap, and it works okay, but I have a problem. These things are really too small to see. So let's make a Minimap marker for the player and for the enemy. On that, how do we do that? I'm going to use an online tool, all right, called Photop. Photop, I'm not sure why I'm capped. There we go. Photop is a online Photoshop, kind of alternative. Okay, online Photoshop alternative. I'm going to put that link inside of our content. So we'll say Photop. So Photop online Photoshop alternative. That's what it is. There we go. And submit. So this is kind of really cool. And what we want to do with Photop is I want to make a brand new object. I want to say that it's about 100 by 100, 100 height and 100 width. DPI is fine. Background is going to be transparent. It's going to be in pixels, and I'm going to click create. So there's what my background looks like. For Photop, what you can do is if you want to zoom in, you can do two ways using the magnifier here, the zoom tool, or I can use the Alt key, hold the Alt key down, and then scroll in with my wheel. All right, so that's kind of something I want to do. And what I can do is I want to draw a little shape. One thing to note is if I'm going to draw a line, so let's say here, if I'm going to click on underneath here, if you hold down any one of these menus has submenus, just like Photoshop, if I click line, that's cool. Instead of a shape, I want to draw pixels, and I don't want to anti-alias. I found that out the hard way last time. I want to change that width to 1, right? And I want to make sure that the color is going to be black for this one, just as an outline. And one thing I want to do is I'm going to grab, so just zoom in a little bit more. I want to grab this bottom pixel, just way at the bottom here, and grab it. And then I want to kind of move it to the right, to the middle. Notice there's a snap to point in the middle of the screen, which is pretty cool. And do the same thing from that snap to point all the way to the bottom. So there's a snap to point at the bottom. And the same thing for the bottom. I want to go from this part all the way to here. Let's make sure that we actually do it in line on screen. On screen. There we go. That's what I want. So it's got to be on the screen so we can see it. If it's off screen, and you can see that that's on screen right now, that would be bad. And now this is on the background layer. I certainly could do it somewhere else because the background layer is locked, right? Maybe we should do it on somewhere else because we leave the background layer the way it is. It's really up to you. But what I find is if you're going to use the paint bucket tool now and choose a color like green, then we should be able to paint this in here any color we want. Let's try that again. I want a green color, yay, and paint it. There we go. So there's our paint. But the problem is we also got rid of our border. So let's try that again. So paint bucket tool, green. There we go. And that is our little triangle, yay. And I wonder if that little bottom part is out or not. I wonder, because it looks like It's hard to see if this is actually in here or not. It won't show you the ones that aren't, but anyways, this is it. So this file, save as, or export as, we can export as a PNG, and we'll call this, when we save it, we'll go, you see how we did it in the earlier class. I want to go to desktop, and I want to go to GBC and GAME2014 and Lab 10, and I want to put this inside of our assets textures folder. We're going to call this the player marker. There we go. And let's do the same thing, but change the inner color to red. So again, I'm going to go with red and use my paint bucket tool and just change this to red. And then I'll say File, Export as, PNG, Save, and make this the enemy marker and save it as red. So I've got two. I've got a player marker and an enemy marker. And I did it with this online tool, which is an amazing tool for free. Let's go back to our game and let's get into our textures. You can see now that I have an enemy marker and a player marker. Pretty good. They're both 100 by 100. And you can see a preview of what they're going to look like here. Not bad. I want to add a player marker to the player and an enemy marker to the enemy. In the minimap, I don't want to see the player and the enemy, just the marker. So let's do the player first. So in the player, I want to grab the player marker and drag and drop it in. If I do, it becomes a sprite renderer that I cannot see. Why? Because the order and layer should be the same as the player. And it should also be reset. There we go. Notice that it is actually behind the player because that's where it appears to be, because the order and layer relative to the player is 1. Let's make it 2, so it's on top of the player. And let's make it so that it's rotated so it looks where the player is looking. So I'm going to go to the rotation and just put in -90 to kind of make that minimap marker look where the player is looking. I'm also going to adjust the position so it's kind of in the middle of what the player sprite looks like to be. Something that looks like this. Something like that. And then change the size so that it's double the size. So something that looks like this, and then make another little adjustment so that you can see wherever this is, the middle of this thing is the middle of the player. Cool. Now, the thing is, we don't want to see the player in the minimap, right? So if I go back to the minimap, we see this, but we don't want to see the player ever, not even a chance. So I can go into the Minimap Camera, and I only want to see the markers, but not the player. So I can turn player off, but I want to see a marker. So the way to see the marker is to go to the layer, and I want to add another layer. Let's add the marker layer. And I want to say that this player marker is going to be in the marker layer, right? And the Minimap Camera will only see the marker, but not the player. Okay, so that's something that's going to happen now. Cool. Same thing with the enemy. If I go to the enemy, here's our enemies. Enemy doesn't have a layer. Let's add a layer for the enemy. So we'll say this is the enemy layer. And the enemy layer is going to be for all enemies. So enemy, awesome. Just for the object only. And I want to override this for all enemies, right? Apply all. So all enemies have an enemy layer that they're on, right? And the minimap camera should not see the enemy, but rather its marker. So let's, just like before, I'm going to take into this enemy here, right? So that would be probably this one. I want to take the play enemy marker and drag and drop it onto the enemy. And just like before, we don't see it. Let's make it so it's a value of 1. Let's reset the value so it is on top of the enemy. And let's change the rotation so that it is on the z-axis 90 degrees, so it points to the player. Let's multiply this size by 2. And you can see how we're actually seeing it already in the minimap. But let's realign where it's going to be so it's kind of more on top of the enemy and less on top of something else. But we don't see the enemy anyway, we just see this arrow. So the arrow's being seen. Cool? Great, but we don't want to see this in the game. We don't want to see this, because look, if I look at the game right now, we can see these big fat arrows, and those are ugly. We want to see the player animation and the enemies. instead of this. So let's go back to this and we'll say overrides all. So all of them have that now, right? If I look at the scene and I zoom out, you can see that all of them have enemy markers. Great. But we don't want to see them, so we change that in the main camera. In the main camera, we go to the mixed calling mask and we turn off markers. So you don't see markers in the main camera at all. Okay, no main camera. One thing to note is that the player marker is a marker, right? And the player itself should also be updated. Just make sure that that is good. Also, the enemy marker should also be a marker. And we should also go here and override that. So that way only the enemy marker is being seen, but not inside of the play area. Play area, you know, again, you can't see the enemy markers. You only see them inside of the minimap, but not the play. The play camera, no, it doesn't see them, but it does see them in the minimap, and vice versa. We can't see the enemies or the players, but we do see the markers. But there's an annoying piece that's annoying to me, which is we see the markers inside of the editor, and we can turn that off by going to the top right here where it says layers and changing the, we don't want to see markers. We just have to hide those like so. And now we can't see markers in the editor. We only see them in the minimap, and we see them, and we only see them in there, but nowhere else. And we don't see markers the other way around. We don't see the player or the enemy inside the minimap. That is the minimap. And if we run this now, we can clearly see that we see the minimap. Okay. And it might be a little bit more helpful than what we had before. This guy out, kill him. No. No. But you can see where we are. We can see that there's two enemies here and that they're turning around. One of them isn't, right? Oh, I can't make it. You get the picture. You get the idea. Okay, so that's pretty good. I know it's terrible. I'm a terrible player. But the idea is the same. So we've got pretty good play. Well, not pretty good play. Pretty good features, not great play. But let's save that. File, save project. And let's just exit and put that up on GitHub. So for GitHub, we want to make a brand new, we want to use the old repository. So I'm going to say open. I'm going to open a repository and I'm going to go to the desktop. I'm going to go to GBC. I'm going to look at GAME2014 and Lab 10. Select that folder, which is going to open up that repo for the first time. And what we want to do is here is stage all changes. And when we're done, we're going to say added minimap. We're going to commit files to all those, but we have a couple of things to do. The other thing we want to do is modify the Readme file, right? This Readme file we want to change. We didn't do that, so let's go into the project files and double click on the Readme file. Let's change this to week lab 10. That's important. So it says lab 10 instead of lab 9. Automatically, this is going to show that there is a Readme file that's been changed. We'll say updated Readme file again. Right, so we'll stage the changes and we'll commit. And now we want to push, but we don't want to push to the same place. We want to remove the origin remote, right? We want to remove that. We can also edit it, but removing is easier. And then I want to push, but we don't have one. We want to make one, and we're going to choose George Brown College. There we go. And I want to use this name, GAME2014 F2021 Lab 10, and create remote and push references. Something that we've done a few times this semester. Okay, questions so far about the minimap. Would you use it in your code for your game? Thoughts on that one? There's some usefulness for it, in my opinion, but it really depends on the type of game. I think it's great for scrolling games where you have a very big map and you want to take a look. You want to give the player a preview of what's happening. It's good with 3D games, like a first-person shooter. And I think it can be good with platformer games if you use it with care and if you don't make it too pulled back. So it's got to be useful for what you're looking at. So like something like this is okay. Okay, this is great. The next feature I want to add in today is the dust trail. Okay, so dust trail, obviously what we're going to do with the dust trail is we want two things. We want to use a particle system. And when we use the particle system, we want to be able to turn it on and off. That's what we want to be able to do. So particle systems shouldn't run the entire time. Now, there's going to be some complexity here, but let's try this out. So here in the player itself, I want to add a brand new empty. We're going to call this the dust trail. So dust trail, right? And it's not terrible for the dust trail. Let's actually make it so it's dust trail, player marker. We can use full words here. So dust trail is nothing, but let's add a particle system. So the particle system, what we want to do here is we want to make it move, right? And if we look, if I zoom in here for the player themselves, here's the player, we can see that we have particles that are coming out already, but let's look at the dust trail particle system. You can't see it because they're invisible. We're going to see them in a second. All right, so let's do the configuration for the particles. One, the duration is not going to last 5 seconds. It's going to be 0.1, short duration. All right, the start lifetime is going to be 0.5. That's how long it's going to live, right? We are also going to modify the start size. So we're going to start it at 0.1, so quite small. We're not going to make them big. And it's hard to visualize right now because of where they're rendering. Okay, just FYI. We're going to see them in a second. And they're also dark. So we're going to see that change in a bit. Right, so those are the changes first. 0.1, we'll leave looping and start on awake or play on awake on for now for troubleshooting, but we're going to turn these off later. Okay, so next, what we want to do is we want to open up emission and change the emission to something like 200. So more. Okay, just to visualize this, because we can't really see anything, in the renderer, just to be able to see things, let's put in a sprite material, our default sprite material in the material. So we'll say sprites default. So now we can actually see it. It's an actual sprite. There's no color right now, but there will be. Okay, but that's what it looks like so far. And by the way, it's there, but if I look at the environment and I take off in the world the background layer, let's take off the background layer. And if I go back to, because the background layer is occluding, and we'll talk about why. If I go back to the dust trail, now you can actually see that there are these white particles. Okay? And the reason why they weren't being shown is because of the renderer. Under the renderer, if you notice, right, you can see that the order in layer is 0. If we make it to 1, right, and if I put back the background, so put back the background layer, now we can see it again, right? So that was the problem, because inside the renderer component, right, we want to be able to see these little particles. Okay. Okay, next. So let's go back to here. So first of all, we're seeing the emission, but the shape is wrong, right? The shape is kind of like this cone, and we want to make it so that it's a dust trail on the ground, right? So we want to change this from cone to box, okay? It's interesting, you can change the shape of your emitter. That's what we're doing here. And we're going to leave it as volume, but what we're going to do is we're going to change some of these values. So we're going to say that we want both particles on the X scale and the Z scale, but not on the Y scale. So let's change that to 0. Okay, and what we want is for the particle system itself, right now it's kind of way up here, right? We want to kind of render towards the player's feet. So we're going to kind of pull this down to something like, kind of around the player's feet. You can see it, okay? Like 0.93, maybe just go right to -1, just right below the player's feet would be okay. Okay, so that's where it's rendering. So that is the shape. Okay, shape. And the next thing we want to change is velocity over time. So velocity over time basically shows us where these things are going to move to. So we're going to make it go at negative 0.2, right, on the x-axis. So it's going to go behind the player because they're dust trails, and positive on the y-axis, something that looks like this. Okay. So you can see that this is pretty big, right? And like I said, it's okay if you had a scale like this big, but that's a big scale. Let's reduce the scale of the box on the x-axis alone to something like 0.1. So now it's like a little axis like this. And you can specify where you want this to go. Instead of the middle of the player, you can make it go so it's at his heels, something like here. That's where the player's dust trail is going to start from, somewhere back down here. Okay. Problem is that the player dust trail is only going to be here. And the way it would work is if you move it around, you want this dust trail to also move. So if you look at the dust trail, it's minus 0.5 and 1, minus 1. That's where the bottom left corner of the player's foot, let's say. And the reason why it's stuck there and it's not actually trailing anywhere is because of the simulation space. The simulation space is local. Let's change this to world. Right, and now if I moved it, you can see that it actually does these dust trails that we want, right? So that's what we really want. So something again like minus 0.5. There we go. So that is what we want the dust trail to be, okay? We want it to be on, but if we did that and if we ran it right now, just as is, right, we have a couple of problems that we're going to talk about, right? So this is what it can look like. It's always on. So this is the effect we kind of want, but with some care, we want to make this a little better. We can do better than this, right? So that's what we want to do. We want to kind of make the dust trail move around, but we want the dust trails and we can actually modify a couple things. Inside of the shape, we can change the shape. So instead of 0.1, it's like 0.2. 0.2 means how wide it is on the x-axis or how long it is on the x-axis. So again, if I was to go there and modify this, you can see that it's a little better maybe. Right, there we go. Kind of follows through. But it doesn't disappear. It looks like a little snake, and that doesn't make any sense. So what we want to do is we want to make it change our color over lifetime. So color over lifetime means that in the space of the time, right now it starts as pure white, and we don't want this. Instead, what we want to do is if you move the top one just a little bit and put it back, you'll see that there's an alpha transparency value. You want that alpha transparency to be 0 at the end, right? So from the beginning to the end, if it lasts half a second, at the end, it becomes transparent. And we can try this out and see how that looks. So again, we can do it. Right? So it kind of disappears, but it keeps going right now because it's play on awake, right? And it's also looping. And we don't want it to loop. When we're idle, we want it to turn off. So that's where we can add it in. Notice it doesn't show up here in the Minimap, which is a good thing. Okay, cool. So that's the color over lifetime. Color over lifetime. You can add in a bunch of other things too. You can experiment with some of this stuff, like size by speed. So you can change the size of the renderer. So if I turn this on, the faster I go, as an example, then the bigger the speed. So speed range from 0 to 1. And if I was to try that, you can try a bunch of different things out and see what that looks like, right? And maybe what we want to do is change this is the size going from 0 to 1. And we can change the size. We can look at the graph. And we can make that size like up to 10. And then see what it does. Does it make it so that you can see that there's smaller particles, right? And as we go faster and faster, it'll get bigger, right? So maybe 5 would be better, or 4. right? So fast, and as you slow down, particles get smaller, right? So some stuff you can play around with that if you like to modify the effect of this thing. You can also increase things like, for example, I can add noise. I can also add lights to this thing. So I can add a light that is kind of coming out of this thing, and the light is something that it'll make the thing shine and a bunch of other stuff. And also I can add it's more trails to the trail, trails to the particle trail, right? But it becomes a little bit crazy the more you add. So let's just not put those in. I think we've got a pretty good basis for what we want to do, but we have some problems. And one of the things I want to do is I want to be able to change the color, and I want to be able to control the particle trail right from the player behavior. I don't want to keep going inside of um, the particle system itself. I want to leave it as is. I don't want to touch it. And then I want to go in and modify that stuff. So we need a reference to the dust trail, and we need the ability for us to change the color. So those are the two things I want. Let's add that to the player. So I'm going to go override, apply all. Cool. And let's add that script into the player script. So under player behavior, let's go to player behavior. Let's add that part in there to the script and see how we can make this a little better, right? So yeah. So at the top, we have some sound effects. Underneath the sound effects, let's put a new header, which we're going to call dust trail. There's a dust trail. And in the dust trail, we're going to add two things: a public particle system, which we're going to call dust trail, as well as, hold on, as well as a public color, which we're going to choose as the dust trail color. Yeah, those are the two things we want to add in there. We want to control those two things. And so a couple things inside of the start, I want to get reference to the particle system. So again, underneath the jump sound, I want to say that dust trail, well, that just equals get component in children. We know that it's part of our child because it's parented to the player. We can say that that is the particle system that I want. The only particle system that I have is this dust trail. I want to kind of find it automatically as opposed to drag and drop. I don't want to drag and drop if I can. So that's number one. Second thing is I want to be able to control the turning off and turning on of the particle system. So I don't want to always make it on. So at the bottom, I'm going to scroll all the way down to the bottom, and I'm going to add in a new method called create dust trail, right? And I'm going to say that dust trail dot, this is the color part, where I want to get component. So I want to change the component of the dust trail. I want to look at the renderer. This is kind of the same thing we change the color of an object. Renderer dot, and then I want to look at the material, and I want to change the color, right? And I want to look at the color property of the shader, right? This is the color property of the shader. And I want to modify it by my dust trail color, whatever that dust trail color is. That's the first thing. I want to change the renderer. I want to modify the renderer that belongs to the dust trail particle system so that it colors it or tints it with the color that I choose in the inspector. And then I just want to play the dust trail, right? So that's how it's going to work with I'm going to call the create dust trail method to change the color and play the dust trail. Okay. And where do I want that to be done now? So that's the first thing. So now that I've done that, I got to think, do I want it to play on idle? And the answer is no, I don't want to play it on idle. I want to play it when there's two possibilities. One, when I'm moving, okay? And the other one, when I'm falling or jumping. I want to play that. So here is where jump is happening, or I definitely want to make it play here. So I'm going to say create dust trail. So that's where I want to make it play. And when I'm moving, I definitely want to play it here when x is not equal to 0. So let's put that in there. So create dust trail. But I don't want to do it on idle. That doesn't make any sense. So that's something I want to do. And you can also make a case for we don't want to do it on jumping either. It's up to you. I kind of like the effect. Maybe you don't. So that's the next part. So let's go back to here, and we have to do a couple of modifications now to the player. One is change the color, and the other one is make sure that the dust trail, which is a particle system, is not looping, as well as it is not playing a week. We want to turn those two things on. So we want to control when it comes on. There we go. And then the player itself down on the bottom, what we want is instead of the dust trail being a black color, we want to make sure that the dust trail is the color we want to choose. We can choose a color. We can use the eyedropper tool to choose a color that is friendly to us. Like let's say I want to try this lighter color down here. That's the color that I want for the dust trail to come off, this lighter color that we can see relative to the background. One thing to choose, make sure we had this problem before. The alpha transparency by default is set to 0. Make sure you set it all the way on. Otherwise, you won't see a color. And we were like killing ourselves last time going, why can't we see it? Well, because by default, the alpha transparency is 0. That's not cool. All right, so that is good. Let's try it and let's see if it finally works. And the way to test this is take a look here. If we have a reference to the dust trail system, we're good. So then we just jump and we can see that that particle is indeed there. It lasts pretty good, and we can see that it looks okay, right? It doesn't last forever too, because we don't have a way of keeping it on. It's not looping, so it just turns off, right? And that's not bad. So it gives us an idea of where we're going. It makes it exciting to look at and even fall, right? Here's something. Why isn't it working on falling, right? Well, that's one thing that we have to consider. So if we look at the code again, we made it on the jump sounds. It only works on jump, but it doesn't work on fall. If I want to make it work on fall, then I wouldn't put it here. I'd actually put it here when I'm in air control. So in air control, that's when I want to do the jump. And that means when I'm jumping or when I'm falling, it can turn on. Let's try that again, and let's see how that makes a difference. Different kinds of effects, right? And you can have different particle systems. One when you jump, another one when you fall. You can make different sounds when you're falling, right? So now this is different. You can see that that falls and it jumps. Maybe that's what you want to see instead, or you like the truncated version, right? Right? That's an interesting effect. Look at that. So as I'm going, right, it has the particle system everywhere else. It's pretty cool. So that's it. That's the particle system, and it looks pretty good. Okay, great. I love it. Let's save it. File, save project, and let's push this up on GitHub. All right, cool. And let's go into GitKraken and push this up. So again, I'm going to go stage all changes, and I'm going to say added dust trail particle system. There we go, and commit all changes. And I want to push this up to GitHub. So that's this part. All right, and let's relaunch Unity and go from there. So questions so far. Particle system pretty easy. What are your thoughts? Again, this is raw particle system. We can also make a particle system with VFX graph. And I think it's pretty cool what you can do with low code, no code. But I think it's also good to know how to make a raw particle system as well, which I think is just, there's some really cool things you can do to it. You can add particle systems for smoke and fire. You can even add particle systems for a bullet trail. And maybe if you have time, we'll do that this time. Okay, so that's kind of cool. We got our little guy here. The next thing is screen shake. That's what we want to cover. Now, the problem with screen shake right now is that we really don't have some assets for a bullet or anything else like that. And really what we want to do is when we get hit by a bullet, but then we want a screen shake so we can feel that we're getting hit. We're going to do the screen shake first, and then if we can do the bullets, that'll be the extra that we're going to do, you and I, in your second section compared to the first section. Okay, we'll do the bullet firing and the noise and all that stuff. All right, and it's about time because we haven't done bullet firing for our little guy anyway. Okay, cool. So, okay, excellent. We've got our guy. Let's add screen shake. So what is screen shake? Well, we've seen it in Juice It or Lose It, that little video we had on the GDC talk where these two guys came out and they made screen shake and it made a really cool effect. Maybe you guys remember that video from first year. But basically what we can do is in the virtual camera, we have a Cinemachine virtual camera. We're going to use this virtual camera too, and we're going to add in some noise. So on the bottom here where it says noise, we can change this to say basic multi-channel Perlin. We're going to use Perlin noise. And we can choose a noise profile. We're going to use 6D shake. You can choose other ones too, right? I'm going to use 6D shake. And so it has an amplitude and a frequency gain. So when we do this kind of stuff, we don't want to leave the amplitude at 1, because if I leave the amplitude at 1, and if I press go, as an example, just by pressing it, you can see that we're totally shaking all the time, right? And if I change this amplitude up, right, to crazy, we can make the screen shake like insane, right? And it looks just nutty, right? So we don't want that. So we want to start off with this amplitude gain of 0. So no screen shake starting up. We want to control screen shake programmatically. That's what we want to do. And the way to do that, of course, is to add additional features to the player behavior. Let's go to player, go to player, and in the player, we want to go to the, let's just kind of hide some of these things. And then the player behavior, we want to double click on the player behavior item itself. So here we are. And at the top, what we want to do is we add some additional things for our screen shake. So we'll say screen shake properties. So we want to get a reference to the virtual camera itself. That's something that we want to be doing with screen shake. Okay, so one thing we do is we get a reference to the virtual camera. And let's do that first. So we'll say a public reference to the Cinemachine virtual camera, okay, which we're going to call the virtual camera. Okay, that's one thing. And the next thing we want to do is we also want to get a public reference to the Cinemachine basic multi-channel Perlin. This one, which we're going to call Perlin. Okay. We also want to add a couple of features. One of them, we want to modify that the intensity of the shake. We just saw it was pretty intense. We want to modify it with code. So we'll call this the shake intensity. And we also want to modify we want to kind of time how much, how long we shake for. So we're going to say there's two parts, the max shake time, how long we're going to go for. You can also call this the shake duration. So let's just call it duration, right? That's the maximum shake time, as well as the shake timer, public float. And we can call this again, shake timer, just in case we don't want to clash with the duration, right? So we might have other durations in here one day. But shake timer, shake intensity, shake duration. So we know what those mean. And finally, we want to make sure that we want to check to see in the editor, is the camera shaking? So is camera shaking? If the camera's shaking, then we want to not try and shake it again. We only want to shake it when it's not shaking. Okay. Otherwise, we'll have like compounded shaking effects with one compounding the other one. We don't want that. That's even bad the way it is right now. So let's do a little bit of configuration. One is we want to say that is camera shaking starts off as false. We also want to choose that the shake timer is going to start off with the shake duration. Whatever the duration is, we're going to make that initialize the timer as that when we first start. So if the shake duration was half a second, so too is the shake timer. And that's what we're going to make it, half a second. We want to also change the purlin information. So we want to do a couple things. So we're going to say that purlin, right, is equal to, hey, I want to get the virtual camera and I want to get a Cinemachine component, and I want to look at the Cinemachine basic multi-channel purlin option, and that is what the purlin noise function is going to do. It's going to turn it on and turn it off. Now, just to note, we have not made a reference to the virtual camera right now, and before we move on, let's do a couple things. Let's go into the Unity scene, and I want to change the stuff we have in here. Let's make sure that we don't see this anymore. And we see the shake intensity. Let's put that at 5 so we can really be intense. Shake duration shouldn't be more than 0.5. And the is camera shaking and shake timer should be set to nothing. But the virtual camera, I mean, there's a couple ways. We can try and find the virtual camera, but there are 2 of them. So if we did a game object, find object, that of type virtual camera, which one? And what if they were in a different order? And what if there was 5 of them, right? So in this case, I think it might be best if we just drag and drop. Okay. So again, it's not that it's impossible. We just have to name these. We can name these differently. Instead of virtual camera 1, virtual camera 2, we can name them properly, and we can find by name. That's another way of doing it. But for now, I'm just dragging and dropping. Cool. So now that I have the properties that I need in my player controller, I want to be able to activate the shaking effect. So for that, going back to our code, I need another function. I don't need one, but I think it's best that I create one, right? So let's do it. So under create dust trail, I want to add a new private function, which is going to be called create dust trail. There we go. And how about create, how about instead of that, we'll call it shake camera. I already did create dust trail, shake camera. And when I do the shake camera, I want to say that, hey, purlin, I want to have access to, oh man, look at this, m underscore. These are like private variables, m underscore amplitude gain. Remember that amplitude gain? I want to change it to say that that is equal to the shake intensity. And what I also want to say is the camera shaking. Well, it is true. It's shaking. All right. So when I'm causing the timer to the object to shake, it's going to change the intensity of the amplitude. Remember how we modified it in game? Same thing. Cool. What about the timer? Well, that's going to be inside of the fixed update function that we have here. So the fixed update function is going to allow us to set up the timer. So I'm going to say that, okay, if is camera shaking, right? So if it's already shaking, then the shake timer is going to be subtracting my time.delta time. So it's going to count down delta time. So, basically 1 frame at a time. That's what it's going to do. And what we're going to say is if the shake timer, right, is that less than or equal to 0. So if we reach 0, that means we're kind of timed out, right? Then what I want to do is I want to change the purlin amplitude gain back to 0, right? I want to not shake anymore. And I want to set the shake timer back to the duration, right? So shake duration. So I want to reset it, basically, is what's happening here. And finally, is the camera shaking? Well, that's going to be equal to false. I'm going to stop the camera from shaking, which again is going to help us out with some of this stuff. All right, now that we have our timer, so this is kind of our camera shake control, right? This is when it's actually shaking. We can have the timer go and it keeps on going until it stops. And when it stops, it's done. And now we got to think about where to shake it. For now, I want to say this. When I'm falling or jumping, then I want to shake the camera, or we can just have it just for now, just when we are jumping. But if we have time, and I think we do, I'm going to make a bullet, which is kind of outside of what we wanted to do, for our enemy. And when we get hit by the bullet, then awesome, we can use that. So let's say we're going to say shake camera anytime we jump. That's going to be our test to see how this looks. So let's try it and go back to our game. Cool. And let's run this thing and see if it actually works. So right, it's also pretty intense. And look at that timer over here, right? It starts off at 0.5 seconds and it's kind of, you know, it's a little bit too much, right? So again, you can make it more subtle, but we really want it so is when we get hit, the whole place shakes around. Maybe even make a sound that we can see that that thing is shaking. But we know the shaking is working now, so we're good to go. Let's save this, file, save, and file, save project. And let's exit this and put this up on GitHub. So again, go here, and we're going to say view changes. We're going to stage all changes, and we'll say added camera shake. Pretty simple, right? Added camera shake effect, right? There we go. Add a camera shake effect, add it on. And once we're done this, then we can push it to GitHub. Cool. Awesome. Slowly, slowly, we're building this part up. Can I show camera shake again? Sure. Do you want to see it live, or how do you want to see it? Do you want to see the code? Oh, okay. It's coming. All right. So that is here. So camera shake, there's a bunch of parts. The first part is the configuration, this piece. Okay. So again, we want to get access to the virtual camera, a reference. We want to get a reference to the Perlin noise generator that's inside as a component of the virtual camera, right? And again, this is the Cinemachine's basic multi-channel Perlin noise generator. Okay, we can use other ones too, by the way. We want to define shake intensity and shake duration, a shake timer that counts backwards, and also a Boolean that is camera shaking. In the start method, we want to configure is camera shaking to false and shake timer to shake duration. So it's kind of at the beginning. So it'll be at 0.5 in the beginning. We're going to get a reference to the Perlin noise component of the virtual camera. That's what we're doing. That's what this is. And then inside of the fixed update, we're going to do a camera shake control timer. That's what this is. We're going to check to see if the camera is already shaking. And if it is, we're going to say the shake timer is going to count backwards by delta times, seconds or milliseconds, which is usually like, 0.16 seconds every single time, so slowly, 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 it's going to count backwards. So 16 milliseconds. It's going to reduce the shake timer by 16 milliseconds. And if the shake timer is less than or equal to 0, so if we're timed out, then change the amplitude gain to 0, reset the shake timer, and make sure that the camera is not shaking so that it's not going to skip this part, or it's going to skip this part. It's not going to keep timing out. And that is the camera shake control. The other thing we want to go to is the jump to the shake camera method. And the shake camera method is we access the Perlin noise component. We change the amplitude gain to shake intensity, which is an kind of external float that we're going to use in the editor. We're going to modify in the inspector, change that to whatever we want. We're going to set that to 5 by default, and we're going to also set that when we call the shake camera method, that we want to turn is shaking to true. So we're going to change these two values, and then we're going to set the shake camera method only inside the jump action for now for testing, right? Because it really doesn't belong there. So hopefully you got that. All right, but we would really like a couple of additional things. Now we've kind of gone through a bunch of time, and I want to do a couple of additional things here. So one thing that I want to do is add some bullets. Add bullets. So now the bullets are going to be fired by the opossum, right? That's what it's going to have, right? And the opossum, right, it's going to fire bullets when it has line of sight to the player. Okay, so we need a couple things. We need where it's going to fire the bullet from, and what is the bullet that it's going to fire. That is an important piece as well. Okay, so we want to, kind of do the same kind of, we've kind of done the bullet firing script from before, and I don't want to reinvent the wheel here, but let's take a look at the enemy controller and make some changes so we can start firing bullets. Okay, so let's go back to our, to think about how this can be done. Okay, so that's not what I wanted. Got the wrong enemy controller here. No, that's what I want. So yeah, so the enemy controller is something that I want to do, and it's really the this behavior that we want to start thinking about. All right, so if I'm in the enemy controller, I have movement, I have animation for the animation controller, and what I want now is I also have line of sight, right? So that's something that's going to help us. So maybe something like at the bottom, we're going to add another header. And this is going to be the remaining of what we're going to be doing today. We're going to call this bullet firing. It's really his spit. The opossum's going to spit at the player. And we're going to say that there's two parts. I want a bullet spawn position, which is going to be a transform. So bullet spawn. All right, and the bullet spawn location, let's get that in first, so that all opossums are going to have a bullet spawn location, somewhere where they spit from. Okay, so going back to this, right, inside of our code, and if we look at the enemy, and let's look at this enemy here, our first enemy, or this one. Yep. So where do we want this thing to be? Somewhere outside of the colliding area. We don't want the collider or anything like this to be affected. So that is the bullet spawn. So inside the enemy object, let's add in a bullet spawn location, right? And we want this because it's got to be meaningful, to us. That's the thing that we want to do. So where is this thing from a bullet spawn perspective? So let's add that in. So again, we're going to go into create empty object. We're going to call this bullet spawn, and that is what we want. Let's color it. So we're going to make it a different color, right? Let's make it blue, a blue diamond. And we're going to move the bullet spawn again so that it's definitely outside of, definitely outside of the character, something that looks like this. So something in front of the player, not quite where the, the look in front is, but somewhere else. That's where the bullet spawn is going to be. So bullet spawn is going to be right there. Okay, it's a transform. And let's save that. So all of them have it. So I'm going to say that overrides, we're adding a bullet spawn to all of them. Yay, awesome. And a bullet spawn is something that I want to drag and drop inside of the enemy script. So here is the bullet spawn right here. We can drag and drop that in, bullet spawn. Okay, and again, what I want to do is I want to apply all. So all of them have that. So if I look here in the enemy, we can see that in the enemy script, it also has a bullet spawn in all of them. All right, so all of them have the same thing, bullet spawn. And what I want to do now is I want to think about how we're going to get this thing to fire. What else do we need for firing? Well, maybe some kind of fire delay. We've kind of seen that first half of the semester. So float, that's going to be a fire delay. It's almost like there's spit delay, as well as some kind of reference to the player object, which would be nice to have, right? The player object. And the reason why we want access to the player object might be because, we want to be able to reduce the player's health or something like that. For now, let's just put it in as a placeholder, public, and we want to kind of target the object. All right, so we'll say that say it's a game object. I'll call it the player. We don't have that yet, So we'll put it in there. And what we want to do is in the start function, we're going to get a reference to the player just in case we need it. So player is equal to, again, game object, and then dot find object of type player behavior, and we want to get the game object that we want to have access to. The game object is what we want for the player. Okay, so player, game object, we got this. For now, again, we might choose this to be the player behavior script itself. So we want to modify its health or something like that. For now, we just want access to the player just in case we need it. Okay. Other things. How do we fire the bullet, right? And when do we fire the bullet? The only way we want to fire the bullet is if we have line of sight. If we have line of sight, we want to stop moving and fire the bullet. So this is where it's going to happen, right in here. We need a fire bullet script. All right, so again, down at the bottom, we're going to call this a new private void method called fire bullet. And we want to delay the bullet when firing, because we don't want to fire, in a big stream of spit. We want to say that time.frame count, right, percent fire delay. Remember, we did this kind of before. If that is equal to 0, so if it's at 0, and we want to know that there are bullets in the future. We don't have a bullet manager, but we're going to add it in a second. Then what do we want to do? We want to instantiate a bullet. Okay, we want to instantiate a bullet. So for now, let's add a bullet here to our, we're going to instantiate and destroy for now. Okay, that's what we're going to do. So cool. So in bullet firing, we want a bullet prefab, public game object, the bullet prefab. That's what we want. Access to that. And what I want to do here in my bullet prefab is I want to instantiate it when I'm firing a bullet. So in my bullet firing script, when I do fire bullet, put it in the wrong place inside of events. Let's move this method actually up a little bit higher up here. Then I want to instantiate the bullet. So I want to say instantiate, and I want to make the bullet, right? So what do I want to instantiate? The bullet prefab. Where do I want it? At the bullet spawn. That's the bullet spawn point. So I want to instantiate the bullet there every time there's a frame count. That's pretty simple. That's good for testing. That can't be the last thing we do because we need to make it better than this. Especially we learned about using bullet factories and a bullet, kind of a bullet list, what we like to call a bullet pool and so on. Those kind of things is what we want to do. So what do I want to do is I want to fire the bullet, right, when I have line of sight with the player and only then. So let's say animator's false, and we want to do something like bullet fire, right? Fire the bullet. That's what we want to do when we have line of sight. Cool, so that is the bullet fire. Awesome. But we don't have a bullet to fire. So if I go back to the scene, and if I look at the enemy, right, we don't have a bullet prefab. We don't have a bullet prefab. And here's our bullet prefab. It would be nice if we had, right? And it would be nice if the bullet did something, like it moved in a particular direction, right? That would be nice. So if we're moving right or left and all this kind of stuff, well, we could easily make a bullet. We could do that, right? But we have another project that we've used in the past that has bullets and all that stuff. We can do that. But maybe we want to just make one here, right? So some kind of bullet, it doesn't have to be very big, right? If we think about it, it could have a simple color. So we can make a texture for this, right? And we want to think about what makes sense for the bullet to be, right? So how big it's going to be, it's got to be fairly small, like maybe something like 16 by 16, or something like that. Something like the size of a block max is, I think, where I would make it. Okay. So let's do that. So let's make a brand new file, new, and we'll make it something really small. Let's something like that's even in size. We can size it afterwards. Something we can see. So something like 32 by 32. So it's kind of a big bullet, but we're going to size it. So it's, well, maybe actually just make it 16 by 16 because I think that's probably the size I want to make it. Right. So let's create that transparent background, create. That's how big it's going to be. Right. Now, if you want to make it long, you can. Right. We can make it a longer bullet, but I'm going to make it a very simple bullet that's going to be circular, which might be easier for us to deal with. So we don't have to worry about bullet direction right now. Okay. Because we just want to make a little effect. So let's do it. Let's get a different shape. Let's say an ellipse, and we'll draw from the make sure that the color is right. I'm thinking something like a blue color, similar to the opossum, something like a strict blue, right? Again, blue on black or a dark color might be difficult to see, so maybe that would be the outline. Notice we're doing pixels and we're not doing fill. So the outline would be a dark blue. Maybe we have to do an inline, something in the middle that's a light blue. And we can make this bigger so we can kind of get more accurate as we're doing that. So again, we're going to I'm pressing the shift key while I'm doing this so we can see that this is where it's going to be at. Something like, it looks like this. Okay. This is anti-aliased, which is okay as a bullet. This is pretty cool. And it automatically made this, kind of a circle that's in here. If I want to, I can make another circle that's in the circle. So let's choose another color, something that's maybe lighter, right? So something that's up here in that color range. Yeah, maybe something like that. And let's grab, we're going to make it from this point here down to this point, down to this point. So to make it so it's kind of like this. And then you can see that that is the bullet we want. So we can see it, this way, right? And yeah, that's an interesting bullet. Who cares? It's not that, fantastic, but who cares? So again, I'm going to export as a PNG, and we're going to say save. It's going to go here, and we're going to call this the bullet. Okay. And now that we have this, if we go back to Unity, we're going to see in the textures that we have a bullet. Awesome. And it's 100 by 100 pixels. It's pretty small. Let's make sure we size it. So what does it look like when it comes in, right? So did it come in? There we are. And the problem with the renderer is that it's not rendering in the right layer. Let's render it in layer 1. And cool, that's what it looks like. And it's not terribly bad, right, in terms of size. So that's what the size it looks like. We can kind of see it. I think we should make it twice as big. See, I'm probably, maybe even like that. So you can kind of see it in this like squash form, right? So that's where I would want to go with the objects. The bullet might be something that looks like 2 times the scale on the x-axis, like a spit, but 1 time the scale on the other one. I don't know. But it doesn't matter. We'll call this the bullet. And we'll make this, let's make it just proportional. It doesn't matter. So we can see it nice and large. Large. We'll add in a collider for the bullet, which would be a trigger collider. So we'll say that this will be a collider. And we'll make it so it's a circle collider, right? 2D. There we go. Nice and easy with the radius and everything else. And we'll make it a trigger, right? Because that's what we want. And we're not going to make it so that it is, we could make it so that it is a rigid body, right? We could do that. So it's almost like a grenade. So it kind of goes at the player, but then, but that's more challenging to do for us right now. We just wanted to make it go straight at the player. And let's take this bullet and add a bullet behavior, okay? One thing that we need to know with the bullet behavior is the direction that the opossum is firing the bullet, and that we know what that is based on the line of sight calculations. We know the direction vector once we have it, right? So that will be the direction that the bullet is firing. let's do that. And we're going to have to pass this direction to the bullet itself. What is, when we call the bullet itself, we need to somehow pass that information to the bullet when it's moving. Okay, that's something that we need to do. All right, so how does that look? How does that look? Because the bullet controller is the thing that we want to modify first before we have any kind of information about how it goes, right? So again, it's almost like I want to take whatever the direction is that I'm going, and I want to modify that direction for the bullet. So again, I'm just going to do it here. I'm going to add a new component, which is the bullet controller. There's the bullet controller. And I'm going to take the bullet and I'm going to drag and drop it onto the here, this thing right here. And so that is the first part. Let's do some coding. And I want to think about some things that I need. So I need a vector that I need to pass in, right? So I need so we'll call this bullet properties. Okay. And so the first bullet property is the direction, right? And that'll be a vector 3, maybe, which we'll call direction. So the direction is important because we need to know where it's going. Okay, that's important. And the other thing that we need to do is when the bullet is moving, we want to detect when it collides, and if it collides, what happens, right? So if it collides, it should destroy itself, so to speak, right? That's what it should do. And we should use a trigger collider for that. Okay, so that's kind of the thing that we want to do. So we're going to say that, hey, at the end, when it's moving, we're going to do a private void on trigger enter 2D. And we're going to say that it's going to be a collider 2D other. And if the bullet collides with anything, right, then we want it to destroy itself. So we're going to say that destroy this game object. That's what we want. So the bullet gets destroyed when it hits something, anything. Yeah, that's how it's going to work. And we're going to do this check. The on trigger enter. It's going to happen automatically for us. And the other thing we need to do is make a move function. So we're going to say private void move. And we're going to move the bullet in a couple of ways. We want to use some kind of speed function. So maybe some kind of vertical speed or a velocity. Let's call this the vertical speed or just speed. Public. And we're going to make this a float. We're going to call this, we'll call it speed, not vertical speed in this case, because it can go anywhere you want. So the speed, it's going to say that when we have the bullet, we're going to start off with some kind of, we're going to reposition it. So transform dot position, and we're going to say plus equals to the direction vector multiplied by the speed, and we're going to multiply this by time dot delta time so that it's scaled along with the game. So wherever the direction is it's going, it's going to go to that. So questions. How do we set the direction? The direction is going to be set up. We have to modify the direction of the bullet that we're creating before we, when we instantiate. We instantiate the object, and then we want to kind of modify it as we go. Well, we can do that. So let's go back to our code. So we have that bullet happen, and we can set the speed of the bullet because that is important. So in order for us to do that, because we want to basically give the bullet some kind of speed at all, right? So let's put the speed at something like 4, right? The direction, we don't know what it is. The direction is a vector 3. We want to set the direction based on, you know, when we instantiate. Okay, so that's the bullet. Let's take this bullet and make it into a prefab. So bullet, pretty simple. And that bullet prefab is something that we want to instantiate inside of our opossum object. So again, going back to our code, I'm going to go back into my enemy controller. And so yes, we get our bullet prefab, and then we want to fire it, right? But we can't just do fire bullet like this. We instantiate, but we want to call this object something. Like, for example, we're going to make this, we'll call it something like bullet, and maybe like temp bullet, temp bullet. That's equal to when we instantiate, we get a reference to the game object itself. And then what we can do is, once we have a reference to the game object, we can say that we want to set something around this bullet. Remember, the temp bullet is a bullet prefab. That's what we want to do, right? And the bullet prefab that we want is, we want to configure it with some kind of things like speed or direction. We can't do that to this because this just instantiates a game object. But could we cast it? Can we say something like, as, you know, our bullet? We can't really do a bullet controller, right? Because that's not really how it is, right? And could I kind of modify the bullet prefab itself? Could I kind of say that there's a bullet prefab that we want to mess with first and then do something? Because bullet prefab, you can say that bullet prefab dots, and we know it is a game object. That's all it is. So again, we don't have the ability for us to do that, right? To cast the bullet prefab as a type of bullet. So how do we set the direction? How do we do that? Because we can't do that here. What would you do? How would we change this, guys? Let's see if you guys are with me still. Are you with me? So, okay. So again, what we want to do is we want to be able to set that direction every single time. And we got to think about, if we're going to use a factory, how can the direction be set, right? Once we get the bullet itself, right? Then we want to be able to set the direction towards the thing that we're firing. Okay, that's what we want to do. We want to be able to set the direction. And direction is a public property of the bullet itself. Okay, so something to think about. So when we create a bullet, when we instantiate it, when we create it, the factory, if I was going to use a factory, I would create it. But the bullet manager itself would be the thing that would fire the bullet. That would be the thing. So in the future, we've done this before. We can add bullets into a bullet pool, right? Based on how many bullets I want. Okay, we've kind of done this before. So if we're going to go there, then we want to be able to configure the bullet, right? So instantiate it and create it. And once we make, the bullet the way we want it, right? Then how do I set the bullet, in the direction that I want? Okay, that's the thing that we want to be able to do, right? So we can do it like this. We can say that when we instantiate the bullet, we can look at, hey, bullet, let's, I want to, because the bullet is a game object, can I not do a get? Let's get rid of this. That's what's causing the issue. Can we not do a get component? I want to say, hey, temp bullet, can I get component of the bullet that is the bullet controller, right? That's what I want, the bullet controller component, right? It is a bullet, that's what we're getting. And I want it on the bullet component, I want to change the direction to whatever direction I want. It's going to be equal to the direction of the player, which is this, right? So wherever the direction of the player is, that is what I'm drawing the line from my looking from position to the collider transform. But I don't have a way of getting the player's direction. And we do have the player, right? We know that. That's why I got the player quickly. So I could say that the player is the location. If we're firing, we already can see the player. So we can just say that the direction, if we're saying the direction, that's going to be equal to the player dot transform dot position. So that is going to be the direction of the bullet. So we instantiate the bullet, it's in the scene, and now put it in the right spot. Is this instantiating the bullet as a child of the bullet spawn? No, it is not. The only way that you can make it a child of the bullet spawn is if you were to change its parent. Okay? So that's okay. But this is okay, right? What this does is it changes the direction of the bullet based on getting a component with the bullet controllers. We're actually modifying the bullet, the property of the bullet by accessing the bullet controller method itself, or bullet controller's script that's latched onto the bullet. All right, that's what this does. So that's good. So we've done that, and we're going to do that every single time. Again, not the most fantastic. We can do better, but we're doing this to get going so that we can start firing bullets at the player. And then we can do screen shake. All right, cool. So let's go back to this and let's modify. So the bullet has some information. It's going to find the player in the scene. The player is going to exist in the scene. Let's look at this as an example. Right, here's the player. It's going to find the bullet. It's going to find the player in the scene, and it's going to hit them. Right, it's going to be fired in the direction of the player. Right, we don't need this anymore because that is just the thing we made the prefab with. So thank you very much. In the enemies are going to have a bullet spawn location, all of them, right? So that is where the bullet's going to come from, okay? And we're also going to have a line of sight. It's going to spit the bullet at the player, and hopefully, if it hits them, we can make a screen shake thing happen, okay? Let's see if that works. So first, let's see if it fires. What happens? Does it work? Am I crazy? You know, these are all things that we want to do. Well, where's my bullet firing? How come I'm not instantiating? Right? Well, let's take a look. So I'm going to go back to that character and let's see what's happening. I mean, I definitely have range. Let's grab that enemy. Where's that enemy? Well, there's no bullet prefab. How about that? So enemies don't have a bullet prefab. Let's drag and drop that in. How about that? We don't have reference to the player, but they will. Let's try that again. So the player is going to be something that all the enemies know what who the player is. There we go. Fire delay, that's something we have to modify too. We haven't said what the fire delay is going to be. Right now it's 0 frames, and that is a negative. That doesn't make any sense. The fire delay's got to be something, and that's why it hasn't worked. Let's make it so it's every 20 frames. It's not too crazy, just like we've done before in the past. And let's play that again. So things that were missing in the controller, right? But that's only for one enemy. Let's make sure that we override for all of them. And let's try it again. Okay, so what's happening here? How come I've configured it. Oh, there's a bullet, but it's just sitting there. it instantiated, but the bullet is, let's take a look at that bullet. What's happening? So bullet, oh, whoa, whoa. We got a lot of bullets here, right? And there's the direction that they're going. I'm not locked or anything. And they're all on top of each other. All right. So they instantiated, yay, right? And they probably are going to keep instantiating every 20 frames. Look, they keep on adding more of them, right? But why aren't they moving? What's happening? So why isn't the bullet moving? Well, let's take a look. So direction we have, right? We've set the direction. So why isn't the bullet moving at all? Well, we're not calling the function probably. Let's take a look. I bet you. So inside of the enemy controller, we have fire bullet, right? And inside the bullet controller, we have a move function, but we're not moving. Move bullet. There we go. All right, let's go back. So little silly things we forgot. Try it one more time. Okay, whoa, what happened? Okay, it says that enemy line of sight, game object, compare tag player, and enemy line of sight, compare collider list, game object, player tag player. If that's true, this is where it's aiming. It's saying that there's a problem because there's something in between and it's going in a weird direction, right? The player location is where it's going. That's the direction it's going in, right? So that is weird. Okay. Let's go back to that and fix the problem. I know what's happening here. One thing we didn't take into account is, remember that we have that weird line of sight thing? That weird line of sight thing is detecting the bullet as a thing, and it's kind of before anything else. That's a problem. We need to ignore the bullet as part of its thing that it's looking at, right? So line of sight for our little guy, and this is for the opossum, the enemy. Here it is. So line of sight, it has line of sight. The layer mask and the wall layer mask is good, but well, that is an issue, right, with us. We have to think about how it can ignore because right now it has wall in there and it has enemy, but we definitely want to ignore we want it to ignore the bullet itself. So that's something that's happening. It says missing reference type, exception type, circle collider 2D has been destroyed, but you are still trying to access it, right? Because we went there and then it hit something and we're trying to access it because it saw it. Because remember, it's going to see all things, right? And that is an issue. That is an issue with the way we do line of sight. Circle collider 2D is being destroyed but it's been detected. That's an issue. All right, so that's a problem we have to deal with. The other thing we have to deal with is the direction that this thing is firing. This direction is incorrect. All right, so let's go back to the bullet firing thing and check it out. So bullets. All right, cool. We want the direction plus equals to direction times the speeds, whatever the transform position is, we're adding direction to it, and then multiply by speed, and then times time dot delta time. Okay, but what about when the enemy controller sets up the bullet to be fired in the fire bullet method? Go to definition. It says that the direction is the player transform position. No. Nope. That is not what we want. What we want is the player's transform position minus, we want to normalize this. So we want some kind of normalization function, like a victor3.normalize. And we want to normalize the player transform position minus the enemy position, or the spawn point, if you will, which is the bullet spawn, right? So minus the bullet spawn dot position. So we want that to be the direction that it's going in. Okay, let's try that first, then we'll fix the other thing. We're still going to have that error. And let's see if you agree with this kind of insanity. All right, back to this. And let's see what's happening here. And just to make this speed up, I'm just going to grab this block for now instead of jumping over it all the time. And we're just going to turn it off so we don't see it. So I don't have to actually be on the platform for him to fire at me. Just want to see what happens. So oh, okay, well that's weird, right? They go in whatever direction he's going because, like Herman said, right? They're under the bullet spawn method, and we don't want them to be that way. So that's something that's a problem. So we don't want them to be spawned from there. That is another issue. And they're going quite slow, but that's okay. Slow is good. One thing at a time. So yeah. So fire bullet, enemy controller. We want to instantiate a bullet, right? And bullet spawn is the location. So remember, instantiate says what is the transform, right? Well, this is where we want it to spawn from, right? This is where we're instantiating it, right? What other instantiate options are there? If I was going to do instantiate, what else can I do? So this is the position, right? Not the transform. So what I've done is actually made it the transform because I didn't put the position in there. I was hoping to make it the position. So that was another mistake. It's bullet spawn dot position, which is kind of what Herman was saying earlier. I just didn't quite understand what he was saying. Yay. So that is where it's going to go, bullet prefab, and we want it to go in the direction of quaternion identity. That is something that's going to be something I have to add. If I'm going to make this position, this is going to be quaternion identity for no rotation. Okay, getting closer. These are things we know already, but we're just messing up because we're just doing this on the fly. And run it again. So get closer. Okay, now here's that thing. It says missing reference, right? Missing reference here. And it says that what's happening is your script should either check, but now we have another issue. Now the object is colliding and it's destroying itself on touching anything. And we don't want it to destroy itself on anything. We want it to destroy itself when it touches either a platform or a player, but as long as the other dot compare tag or the other thing that we're hitting is not anything to do with the other, because it can hit any other trigger collider and it'll break. That's what we're saying, right? And that's in the bullet controller. So in the bullet controller, we're saying anytime it hits something, anything, destroy it. Okay, I like it. Well, let's be a little bit more specific. So we're going to say, cool. Well, what about if it hits either the player for now or a platform? If other dot game object dot compare tag, and maybe we'll do a switch because there's more than one. So we'll switch it, right? And maybe we'll switch it on, instead of compare tag, we'll say name. So we'll say that case, if it's platform, then break, and case, if it's player, then also break. And if it's either platform or player, for now, we'll say the same thing, but maybe when you hit the player, it'll do some kind of other things to it. For now, we'll keep them the same, it's the exact same, but we'll add some additional things inside of the player when it gets hit. So destroy it, but before we destroy it, do something. Some things we can do there. Okay, but we won't destroy it when it hits, something else. And this still may fail because platform means that when we hit the platform, if it's inside of that weird range, it's going to destroy the circle, and that's going to be bad too. So we're going to think about how to fix this problem in different ways. Cool. Let's try it again. But this is good because we're seeing the problems, limitations to our line of sight script. Fire me already. Okay, so it disappeared. Now, how did it disappear? Where did it go to? How come it kept on going, and all of a sudden it disappears like that? I didn't even tell it to disappear. What did it hit? Here's something else. What is the direction? Are the bullets really gone? Bullets are not gone, right? Or are they? But they have a z-axis, right? And that is a real issue. They have a z-axis, right? The z-axis should not be a thing, right? Right? They should only fire in one direction, no z-axis, because they'll disappear because they'll go into the screen. So whenever we instantiate the bullet and we go in the direction vector that we get, whatever that is, it's going to say, we're going to do one of these. We're going to say direction dot z is, we're going to just get rid of that. We're going to wipe that out. So no direction dot z. So we don't care, even if it's set for us, we're going to ignore it. Okay. One more time. Now it should last forever. And we have to think about when it hits something, what's going to happen. And it's pretty slow. Maybe we want to increase the speed of that too. That works okay. And now these guys should go on forever. So now we can think about, do we want them to go away after a time? You know, they're traveling pretty slow and they're going to keep going forever and ever, right? So that is something we want to get rid of as well. So we want to say that, okay, cool. If they enter this or this, they get destroyed, but they should also get destroyed after a bit of a time, which means the bullets, when they're moving, should have a timer. So we can sit there and say, we can do that whole timer, the duration and all that stuff like we did before. So public, you can also use a coroutine, but let's just do this. So public will say duration, which is a float. And we'll also have a timer, public float timer, right? And we'll sit there and say that in the start, the timer is equal to the duration, right? And what we're going to do is we're going to say we're going to modify the timer, right, every frame, right? So we're going to reduce the timer, you know, to little by little. So we're going to say timer minus equal to time dot delta time. So we'll change that. So the timer is going to be counting down, counting down, counting down. And then we'll say if the timer is less than or equal to 0.0f, this is the timer, then what do I want to do? I want to destroy itself again, this object. So that's another way it can be destroyed, through the timer. So it's going to time out, and then if it goes long enough, it's going to be gone. We can make it last, let's say, a whole second, worst case scenario. Back to the bullet, back to the drawing board for bullets. So bullet, okay, we say that the duration is going to be a whole second, and the timer is going to start off at 0. The speed, let's increase the speed to something like 6, right? See what happens there. And let's go and do it and see if that's long enough. And then we'll get into the other problem that we're going to have. What happened? Well, it destroyed the script, but it didn't last so long. And so obviously a duration of 1 is no good. Let's say a duration of 5, that might be okay. And we don't want to destroy this. We want to destroy this .game object. Ooh, comedy of errors. All right, let's try that again. And let's do it. 6 is still pretty slow, huh? Oh, just got destroyed there, or it hit the object. Okay, that's what I was looking at. I was trying to figure out. It was inside of the collider, but the problem with that was that we don't really care about bullets, but it cares because it's tracked it inside of its collision matrix. So again, what we're saying is the enemy, right, has the bullet inside of its the line of sight. It's got a kind of a list of in its line of sight right here. It has a collides with, and there's a contact filter. And what we're saying is we want to collide with everything platform, wall, and player, but we don't care if it's something else like a bullet, and we should ignore a bullet because somehow it's keeping track of it. Poof. And this is the layer mask we're using. Here's the mixed layer mask. Here's the line of sight script. So the mixed layer mask says player, wall, platform, wall, and player, but there's nothing to say about bullet. Let's make sure that the bullet has its own layer. So layer mask, let's add it in there and put in bullet. Otherwise, we don't want the bullet to be something that is there. Okay, so save. Let's make sure we go to the bullet and add that in. Excellent. And we definitely, inside of the enemy, right, we want to avoid bullet. We don't want to click that on, right? So now it's not there anymore, which is a good thing. Okay, great. So even if it's detected, even if it happens, the collider list is what we want to look at here for this guy, right? And I want to take a look at that collider list. It should never, ever, the bullet should never even be there, ever. Let's see if it is. And if not, we can do the physics properties in the generic physics properties in the game. All right, so let's do that. Never want to see that bullet in there. I'm going to duplicate that error we had before. So again, he's only going to fire at me when I'm there. Let's do here. Let's see what happens when, and does he going to get confused here if he's going to keep on? There it is. All right, so now let's take a look. So it says collides with, and this is the issue, missing collider. Because as it hits, it gets destroyed, right? So why is that? Because the line of sight script, let's go there. Line of sight script, what it does, it says we have a polygon collider, and it says on trigger enter with any other polygon collider, right? That's what we're getting here. That's where the issue is coming with. The line of sight collider doesn't care, or the line of sight itself doesn't care about what type of thing you're entering, right? It could be anything, including, the bullets. We want to ignore this. So we don't want to say, as long as it's not a bullet, because that doesn't make sense. So we're going to say if other dot, and again, we want to game object dot compare tag. If it's not a bullet, okay, we don't want the bullet to be a thing. But now the thing is, compare tag is bad because compare tag, it's the problem with the other being a compare tag is that bullet is not always a bullet, is it? Bullets are actually bullet clones, right? So that is an issue because when we instantiate, we clone the bullet and we don't know what it's going to be. So what is another way of detecting the bullet? We can't look at bullets at all. We want to ignore bullets, period. The end when it comes to this. What else? Because remember, what we're going to say is collides with is equal to other, but what if the other is something to do with bullet? We don't want it to be, right? So that's what gets added in. That's what it gets here and collides with. And collides with is what we're having a problem with. And really, we're only doing it here in our collides with area just because we're using it for debugging purposes. We don't need to see this. We definitely need it, right? Because collides with is something that we're going to check, right? But we don't want to do it for anything that's a bullet. Okay, so how do we do that? We're using onTrigger enter 2D. We want to avoid it. We want to make sure that it's not what it's supposed to do. Well, there's a couple of tricks, hacks. I'm going to give you a hack right now, and then we'll talk about it. So again, bullet controller. So when it gets instantiated, there's a couple things we can do. We can say that the name, we can change it to whatever we want. We're going to say this is bullet. We can change it to that, right? So even if a bullet has clone into it, it'll rename to bullet, okay? And then we can just say compare tag bullet. That will work then, right? And then we can say collides with other, as long as it's not this. If not other game object compare tag bullet, if it's not bullet, then assign it. Otherwise, ignore it. Okay. So that means that if we go here, we shouldn't see collides with anymore into bullet. Shouldn't see that. All right, so tag bullet is not defined, right? So tag bullet is not defined. Undo. So what does that mean? So it says, okay, this is something interesting. Bullet is not defined, but meanwhile we know it is, right, in our current stack. That's a new one. So bullet is not defined, and we know it is. It's right here. Look at that. That's a glitch and a half. Let's clear that. So why is that? Let's try that again. Okay. How about we haven't assigned it to anything? So what about this bullet? Has it been assigned the bullet prefab? The bullet layer it has, but our compare tag, it's never anything. It's never been bullet. So let's add a tag and we'll call it bullet. You know what? We did the wrong thing. We did the wrong thing. So we were trying to be smart, but actually we got smarter ourselves. Instead of the bullet itself changing its name, we don't care about its name. How about a tag? We can say that the tag is equal to bullet. Okay, there we go. We'll tag it. And actually, that is something we can do in the bullet prefab, just in case, which will save us the trouble because we're checking for not the name, but the tag. I'll be okay because I'm going nonstop. And let's use that. There we go. Awesome. That's why it's never been defined. That's why it's giving me this error. Cool. And we don't need to do this part because it's okay. We can just compare tag in here. So we're saying if it's not a bullet, then we're good. As long as it's not a bullet. All right. Whew. Let's see if that's an issue. Okay, let's move again. One more time. Still pretty slow. So again, I think what I want to try is for the bullet, it's moving at a speed of 6. Let's move it 10. A little bit faster. And let's get ourselves in this platform. It's just going to be easier to test with. Oh. Okay. And this way we can test to see if he's ever going to see that bullet, and he shouldn't, right? Because the bullets will be destroyed. And it's pretty clumpy. Okay, long enough. So we know that that's happening and it's good. Now when the player gets hit, then we want the screen shake to happen, not when he's jumping around. Okay, so we want to make the screen shake when the player is hit. Okay, so now I want you to think about how that can happen. Is that a layer instead of a tag? No, we made it a tag, not a layer. We put it both just in case we want to do that, but I think all we needed was this. Okay, so again, how do we make the everything shake when the player is gotten hit, right? So the player gets hit, and then we want to make everything shake. That's the only time I want to do that. So it's pretty simple. I'm going to go back to the player themselves. Let's go back to the player, and in the player behavior, we know that we have a couple things, right? We have a check if grounded and on collision enter 2D and exit 2D, but we care about an event. We kind of put these in the wrong spots, didn't we? Let's put these in the right spots. I want to put these above events and below flip animation here. That makes more sense. And yep, this is our event for on collision enter 2D and on exit collision exit. These are for actual collisions, right? We want to set the parent transform. Now we want to do it for triggers. So we want to say the same thing. Let's say private void on trigger enter 2D, and we'll say collision enter 2D other collider 2D, and we'll say that if the other dot game object dot compare tag is the bullet, this is the place we want to shake the screen. Okay, I want to call the screen shake effect here, or shake screen. I think we'll call it shake screen, shake camera. There we go. So shake camera is only when we collide with the trigger that's a bullet, and that's when we want to shake the camera. Now, here's something. We're destroying ourselves also when the bullet is something that we're shaking, right? We're destroying the bullet when it hits us, right? And that's when we're doing it. And remember I said that in the bullet controller, we're also doing it this way as well, right? The bullet is hitting us and we're destroying the game object, right? Maybe what we can do is, because we don't have access to the player, we could actually get access to the player from the bullet as well, and then say when the player hits the bullet, do damage or screen shake. The problem is that this is going to be destroying the object when it's happening. So if we did it here, if we did it before we destroyed the bullet, then that's okay. But after we've destroyed the bullet, it's gone. So that's something to note. I think it'll still work here because we're going to get the bullet. It's going to destroy itself, but we've detected the collision and we're going to shake the camera. We want to take this camera shaking away from where we have it right now, which is inside of the jump, because that seems to be too destructive. And let's see if this works. And we need two more things after this to make it a little bit better. For camera shake. Right? Boom, 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 boom. Every time he gets hit, you can see that now it makes more sense. It's a pretty violent shake though, right? When he's getting hit. So we can take this shake down a little bit. Maybe we'll take it down to like a 2, right? Because that might make it a little bit less crazy than a 5. 5 is really apparent. 2 may not be so bad. Yeah. Right? It's not bad. Still pretty good, but not as bad as 5. 5 is insane. And we can check it too if we want to make it so it's like, 1, what does 1 look like? 1 is a bit of a shake, but not much. And what does 10 look like? So that's like crazy, right? We shake the entire screen like it's like going to be an earthquake, right? So 1 might be even okay. Let's say, yeah, that's pretty good. The camera shakes a little bit when we get hit, right? It's not as violent as a 2. So 1 might be good enough. really low amplitude gain. All right, now we need a couple things. We need a hit sound and a bullet sound, and then we're done. So again, for a hit sound and a bullet sound, I like to use chip tone. So I'm going to go up here and do that. So chip tone. And let's go there and sure. And then in the chip tone, we'll say the hurt sound. That's pretty good. I'm not going to be picky. And we'll put it under assets and sounds. So audio, impulse sounds, and we'll say that this is the hit sound. Hit. Yeah, there we go. Save. And we also want a sound for an attack. So what about this one? Or a zap? Okay, that doesn't sound too good. Maybe, I guess that's okay, but it sounds like, it's more like a spit sound, like a blip. And maybe make it so it's like this. No. That's better. I like that. It's like something like that. Let's see. Yeah. Cool. I like that. Let's use that as the spit sound. So we'll say this is the spit sound. Spit. Okay, so whenever the thing spits, it's going to make that noise. And let's put that inside of the audio. So inside impulse sounds, we have a spit and a hit and a jump. Cool. Let's go into the enemy. And whenever they do that, we'll add a spit sound in there as well. So again, first of all, let's make sure that all of these are good. Make sure there's no overrides anywhere. So I know I've been modifying each of these things. That's good. So let's go back into the enemy prefab themselves. There it is. And I want to drag and drop a sound in there. Let's do that. So under audio impulse, we'll do a spit sound. And we'll kind of move it up. And maybe move it up again. Cool. And that audio source is not going to play on awake. It's only going to play when I spit. So that's going to be the audio sound. Let's get into that enemy controller again. And we're going to say that in the enemy controller, when we bullet fire, we also want to get a sound here as well. So we're going to say a public audio source, which is going to be the spit sound. Okay. And we're going to get a reference to it here. So we're going to say spit sound is equal to get components audio source, the only audio source we have so far. And we're going to make that spit sound every time we fire a bullet. So let's try that first. So fire bullet whenever we do. And I don't like this. We can maybe make a timer instead. We're going to play that spit sound. So we're going to say spit sound dot play. Okay, so play that spit sound every time we can fire. And let's see how that looks. Well, reference error. Why? What? Okay, cool. When I get hit, the player, they're going to make the get hit sound. So that it's going to be hit when I get hit with the bullet, right? And it's going to shake the camera, which means I need an audio source, which is the second audio source that I need. So now, because we have two, we need a list of audio sources, not just one audio source. And what we did before was we said the jump sound is, part of that list, but we can't do it this way. A couple ways we can do it is we can drag and drop, or instead of dragging and dropping, we can have an array of audio sources, and there'll be jump sound as one, and the other one will be so we could say, for example, instead of a public audio source, we can have a public audio source list. So a list of audio sources, which we'll call audio sources, that we can have. And what we want to do is we want to have our audio sources automatic. So we can say something like audio sources, right, is get components that of type audio source, get components, right? And it says the audio source components. Let's try this out. So if I go to get components, right, and then it's a component array, right? So I will say audio sources, audio sources of type, and then I want to convert this to list is what I want, to list. So that it converts an array to a list and it stores it inside of my audio sources array. This is great, but we need to do a couple things here. This is okay, but I want the jump sound and the spit sound to be an audio source type. So I'm going to say public jump sound, right, which is an audio source, right? And I also want a public spit sound, which is also an audio source, so spit sound. And so we can say that when we get the list of audio sources, we're going to say that the first one is the jump sound. So we're going to say that jump sound is equal to audio sources 0. Again, this is not great, but it's the first thing. And the spit sound is equal to audio sources 1, right? Not a great way of doing it, but this is kind of aligning or assigning sounds. So assign sounds. Okay. And what we need for this is we're going to get everything is going to be set up. So we get all the stuff that we're doing so far, the jump sound play and so on, that's still going to work. When we get hit, I get hit and I make the camera shake. So I get hit by when the bullet hits me, then I can say that, you know, my hit sound is what I want to get hit with, not the spit sound, but rather the hit sound. That's something that I want to change. Okay, hit sound. Hit sound. Wow. All right. So we'll say hit sound dot play. All right, so that's what that's going to do, but we need a reference to it. We can't forget that. So in the player itself, getting this. In the player itself, we're going to get a reference to another audio. We have one audio source, and let's go into the player prefab and add in another one. So I'm going to get that audio impulse. I got the hit sound, and I'm going to drag and drop it into the player. That was weird. Oh, I see what's happened. So this, the jump sound, it just replaced it. Let's add another component in there, audio source. And we'll move it up. Luckily, we're in the prefab too. So the first one is the jump sound, and the second one is going to be the hit sound, which we're not going to play on awake. Phew. All right, good. So let's see if this works now. All right, maybe I made a mistake, but we'll fix it. So how does this work? All right, what the heck is this? I want to know what that is. I'm getting a weird error. Try that again. No reference exception, and it's not even pointing anywhere. Where it says object reference, not instance of an object. But I'm just going to take a look at this for a second. Let's pause the sound for a second here while we do that. So it says, this is a glitch and a half. Object reference not set. Edge, graphs edge at. Graphs do wake up edges. System that collections are generic and edges. Some kind of generic issue. Okay, well, let's see what happened. Did we get a list in player? So if I go to the player, hello player, and no, that's the on-screen controls. I want the player object, this guy. There we go, player. Here's the jump and the hit sound. And I can see I got the player jump and hit there. Those are the two audio sources. That's good. And per the noise, that is really weird. I don't know what that is, but I'm gonna ignore it for now. These guys can't hit me, right? Oh, look at that guy. That was cool. That guy hit me like way down here. He saw me, and that was weird. He kind of did one of those weird things, and he started to cast bullets, and I went right through the platform. Crazy. All right, so that is another weird thing too. So the moving platform, which we had before, so these are like little glitches we're going to fix. The moving platform has a layer and a tag of platform. All right, so that's one thing that's going to happen. And we say that if the bullet hits the platform, it should die. But remember, for the collider, for the trigger collider to work, it needs a rigid body. If there's no rigid body, no collision. So there's a couple of things we can do here. We can add a rigid body to each bullet. We could do that, right? And then it would automatically collide with whatever, right? That is a fix for this problem. So if I go back to my prefabs, and if I go to my bullet, right, we can add a rigid body. Well, we can make it kinematic. It doesn't have to be something that takes gravity and all that stuff. So here's our rigid body. Yeah, that is really weird. Okay, here it is. So we're going to move this up, move up. Okay, and let's move it up one more time. Move up. And then the rigid body, we're going to say that we are not going to use mass or gravity. We're not going to use mass or gravity. So instead of it being dynamic, it's going to be kinematic. Okay, so we're not going to use it. But we're going to use it for context. All right, so that's what we're going to do, right? So that's what we're going to use it for. It uses discrete collision detection. We can use continuous for bullets if we really want to, which makes sense. But if there's a lot of them, that's going to be really computationally expensive. So let's try that again, and let's see if that makes a difference. It shouldn't go through the platforms anymore. Right, that is really bothering me, that thing. Yeah, let's see if it does it again. Getting it from this side, and that's weird. Look at that. That's weird. That's like they're not really colliding with platforms at all, because otherwise they would be Gone. Even the other bullets, they're not colliding with platforms. So that means that it's interesting. I mean, again, I think it's an interesting problem, and we couldn't test it before. But I wonder if it's because under the world platform layer, even though we have a rigid body, it's static. It's static, and we're not making it kinematic. I wonder if we made it kinematic instead of static, if that would work, and we want to use full kinematic context. I wonder if that would work better. We'll see in a second, won't we? It shouldn't be, well, this is weird anyway, but it shouldn't be the case where they're firing bullets like that. Where the player was is where they're firing, clearly. But why is it not disappearing when it goes through? Let's do the same thing with the moving platform. Let's change our platform. Let's add a component, rigid body 2D. Let's undo that. Moving platform should have a rigid body 2D built into it. So rigid body 2D, let's make sure that it is kinematic. We want to get kinematic contacts. Definitely want that. What about this one though? I thought I made that one kinematic. At least it didn't fall. This is cool. And definitely want to add in some kind of sliding. Is it on a trigger enter? On trigger enter. Yeah, it is. That is the bullet. The bullet and the bullet controller has an on trigger enter 2D. On trigger enter 2D. So it says if it's a platform, the name other.gameobject.name platform, and we shouldn't do name. Instead, that's why it's not working. That's number one. It shouldn't be that. It should be compare tag. So let's go back and look at that. So platform is not platform, it's platform layer. That's why it's failing, right? And names are bad. It should be compare tag. We're comparing it with the tag itself, not the thing. Okay, so that's, so the name is player, that's fine, but it should be, we're going to switch on tag. So we're going to say if the tag is platform, or if the tag is player, that's okay. That should save us a little bit. So again, glitchies, but we found them, right? So far. This is giving me another issue. Oh, damn it. Okay, that's better. But now, here's something. It's looking where the player was when we fired the bullet, not where the player is. But that's okay, but it's because we're on a moving platform, this guy's never going to hit me. Oh, maybe there. But so again, we can think about, is the spit fast enough? Because the spit should be able to hit us pretty quickly. And now that's going back to the enemy behavior again. So let's go back to, we can't be too fast because then it's going to be too hard. But maybe something like, you know, for the spit, when I'm spitting stuff, that's probably pretty slow. Enemy controller. And fire delay is 20. and then the bullet is what is happening. So let's go to the bullet, and the bullet duration and speed. Speed is 10, maybe 20. Let's see how that looks. It's twice the speed. Maybe even that's not good. Oh, that's good. Yeah, I can still dodge them, so it's not impossible, but it's really, really hard when it's close up. Good. Oh, yeah. Now, still not. Whoa. That's really weird still. It's still weird, but that's another thing to find out, isn't it? It's good. All right. Enough. Then I normalize the bullet direction. I did. See, the bullet direction's in the enemy controller. And what I'm saying is when I fire the bullet, I normalize the position where the player was. That's the direction of the bullet. But because the moving platform is happening, every time I fire a bullet, I'm firing with the bullet where the player was, not where the player is. Right? So that's the problem. So that's where the normalization goes into play. Right? So it works when we're close or even when I'm above or below, but if the player is moving, it has a problem. And because it can't calculate where I was, and this is where we got to think about it when we're on a moving platform. Maybe we have a different script that is going to show me the position of the player relative to the platform. So, because imagine we're both relative, so he's right there. I'm not firing above me. I'm firing at the player position. And we're also doing, this is world position, right? World position, platform transform, player transform position is going to be the world position, not the local position, which is what we're going to hit. So this is something we have to think about, right? Because wherever it is, the local position is what we want when we're on the platform. So that's something we have to calculate. Again, I'm not going to do it now because we've already run out of time. But at least we have a couple of things. We have some bullets firing. We have our guy going. One thing I noticed is that we're really sliding a lot. And I thought we had put a material to reduce that. There's the platform material with 0.4 friction and bounciness. Did we not put that in play somewhere? There's our kinematic rigid body. And there's not a material for that. Is there one on the player? Just curious. No. We made it, but we never used it. Let's put that in. So platform, I wonder why we did that. There must have been a reason for that. Let's do that. So platform friction is 0.4, and that should slow me down a little bit. Yeah, because I was bouncing all over the place, right? So I can still avoid them, and I don't have to jump off anymore. That's good. Still a little bit tough. Jumping is hard, but at least I can do it if I hold it down properly enough. Yeah, and we can make it. Good. So it's not impossible to be done. That's good. And the block itself has 0.1 friction. Do we add it to the block? The block has a friction, but not the platform. So that's interesting. Okay, neat. Mass is 0.1 for the block. That's interesting. And what is the mass of our player? Is 0.1. Yeah, we may have to monkey with these numbers again. Gravity scale is pretty high, right? So, but anyways, we've mission accomplished. We have that. And I'm just curious if this is just a Unity crash thing. So file save and file save project, because that's I don't know what that is, null reference object. I think it's just a Unity editor thing. Let me just close it and reopen it and see if it still does it. Yeah, I was thinking, Michael, maybe only on the moving platform. If it's a moving platform, we fire things differently than we would if we're, when we're targeting a player that's not on a moving platform. See if that's an issue. And then we'll build this for mobile and try it out. That'll be the last thing. Yeah, see? So there's no glitch anymore. It's weird. All right, so file, save project. Let's go into our build settings. And let's go and change to Android. And we'll build it for mobile, and that's it. That'll be the last part. Is it? Did you see it on your instance of the project? Check it. Just to check that because you've asked. Let's go prefabs, moving platform. Nope. We should put it on there too, but we don't have it there. So platform, should have it there too. That's weird. That is really strange. Strange-o-matic. We didn't put it anywhere, but we made it. We have a bullet material, which is interesting. What? How did that come to play? Bullet material. Oh, wait. I know why we made that. Let's delete that. We don't need a bullet material. Or do we? Sorry, in the bullets prefab. Yeah, we don't need a bullet material. I don't think. It's using a sprite's default. Right, so yeah, I don't need that bullet material. I don't know how that was created. I guess when I drag and drop it onto the scene. That is definitely a glitcherama. Oh. What the heck happened? What caused that? What did that connect to? Yeah, I know isn't that a glitch and a half, right? So I got this back here, and sorry, just wanted to check here. Environment, worlds. So that's like the background layer. The background layer is missing a material, which is the tile map renderer. Tile map renderer. Wait a minute, what about the foreground layer? Platform layer, sprites default. Tile map renderer. That's what it needs? Wow, okay, whatever. Maybe that's what happened. That's what it was causing me to have an issue, right? Because I dragged and dropped it on here and I changed the material of, wow. Okay, there we go. That's could have been the cause. That's awesome, right? Isn't that amazing? What a weird glitcherama, right? Okay, cool. So now, I love it. Let us build and run. Well, first of all, let's change the player settings. Sorry, that would be bad if we didn't do this. Wow. Wow. Okay, my mind's blown. Not about yours, but that is definitely not what I expected. Okay, and let's do that again. So build and run, which is going to cause me to spark out. What the heck? Oh, lab 9. Okay, so we're going to make this lab 10. Wow. All I'm saying is, wow, guys, that is like crazy, right? Am I right? That is like nutty, right? When I saw that, that was a weird glitch. Terrible glitch, I say. And hopefully we're going to be done after this. Oh, I wonder where the default device is going to be. Is it going to be my Oculus Quest? Because it could go on the Oculus Quest. That would be really weird. Because it says default device. I can't stop it now. Oh, yeah, it's comedy. Anyways, what I'm going to do is, guys, you don't have to stick around for this. Thank you so much for joining. I don't want to keep you on top of 6. I'm GitHub. One thing to note is stuff that we talked about. Make sure that you remember that next week, assignment 2 week. Um, and one thing we also want to keep in mind is what with our final tests. Keep that in mind. And keep in mind what's happening with our final test to make sure that we have everything that we're looking for. Yeah, I know I'm breaking up. Thank you. It's because of this. It's because they're building for mobile. And building for mobile is always destructive. It takes up a lot of my resources. It's bizarre. And it's really strange. It kills my resources for building stuff. It's bizarre. Okay, let's just wait one more second, and I'll say, like I said before, just take a look at this. Make sure that you have everything you need for assignment 2 part 2, as well as, like we said, think about what's happening for the final exam, what we want to do for it, right? As opposed to, do we really want, something like that? I know you guys said, some of you said multiple choice true false, and what I'll do is I will make a decision between now and next week, so that way you know what's happening for the final. Okay. Again, guys, thanks so much for joining. I'm just going to wait for this to load, and then so you can see it go up. If you want to stick around, you can. If not, thank you so much, and we'll see you next week. All right, and does it build? And what did I build it for? That's the main one. Really hoping it doesn't go to my Oculus Quest, because that would be really weird, because it's connected. I'll know in a second. I'll finish building. Yep. Let's see it. See, I got to see it now. If it's going to be here on my Quest, I want to see it. Where is it? Okay. That is really weird. Hold on a second here. I'm just checking it on my Quest. And, okay, that somehow didn't work, and I'm happy because that would have been a really weird thing to happen. Okay. Oh, no, it is working. Here it is. And it's actually playing in my Quest. Wow. I can play it on my Quest, guys. I can't. It's really hard to do without both controllers. Let's see if this works actually. Okay. Ah. Okay. Cool. I'm getting attacked on my Oculus Quest. It works okay. So yeah, weird. I didn't expect it, but it oh yeah, it works on Quest for sure. It's 2D, but it's you can play the game on a Quest, no problem. All right, so that is really strange. Let's just target my Samsung. That's what happens when you do that and stuff like that, and that's okay. Right. Wow. Okay. Hopefully this will build a lot faster than before, because all we're doing is loading it on the Samsung, and we're not making any changes. So hopefully it'll be incremental. But you never can tell. Let's see what happens. All right. All right. So all right. Let's see how this goes. And let's run this. All right. So there's my dude. It's gonna fire at me. Good. And it seems to be we're okay. We're still getting the same effect. And this is all I wanted to check. what happens if we die and do stuff. It's pretty good. Again, there's some little glitchy stuff, but this looks like it works okay, right? We can see what's happening with a mini map. Oh God. Okay. Yes, we jumped over that guy, and that's pretty cool. I wonder what happened to the other guy. Maybe he died, or he's probably in the on the death plane somehow. Cool. All right, so this is great. And it looks like we're okay and we're working fine. Weird. Didn't expect that, but yeah, VR works great. All right, so lots of fun there, having lots of fun. Okay, this is great. So file, save project. And that's the great thing about learning for Android. Anything we build pretty much for 3D can work on VR, but the controls are, we're controlling the camera and everything differently. Now the great thing is, here's something, because I had those controls that we had in place, those the controls we had in our game, right? Then I was able to do the same thing that we've done in the past, which is use those controls, kind of in VR to make it work. So that's pretty cool. So stage all changes, and we'll say we added bullet firing for enemies. Not great, still glitchy, but at least we're starting to get there with all the commits we have in place. And push. So lots of commits that we've made. And then one thing to note is up online here with this thing for lab 10. As you can see, we have 26 commits, and we've been doing it over a few weeks. So I'm sure you guys have probably way more than these on average. And that's how it should work. One commit, approximately one feature, one commit, and you can start adding in more and more as you go. All right, so that's really it for me. I'm just going to put this up on our Blackboard here. I know we're way over time, but here it is. So this is our GitHub link for Lab 10. Okay, so that's it. And hopefully that you learned something, or I didn't kill you guys too much with the stuff that was broken. There's still stuff to fix, and we're going to deal with it next week. Otherwise, good luck. I'm going to stop recording now on YouTube, and then we'll see you next week.